In this section, we're going to be creating a simple top-down 2D driving game where you drive around as a delivery driver, picking up packages, which will change the color of your vehicle when you pick them up, and delivering those packages to a destination. We'll also play around with increasing and decreasing the speed based upon whether you drive over the little boost areas or whether you bump into something. We'll be focusing on the basic fundamentals of C# and programming in this section. We'll be talking about variables, we'll be talking about if statements, we'll be creating some methods, which are the things that make our game do stuff. We'll be playing around with triggers and colliders and also looking at how we make references to things within our code, such as getting components and then being able to access the properties in those components. So it's a very fundamental C# programming section. We'll make a fun little delivery driver game. So let's jump in and get started. Okay, in this lecture, we're going to be talking about the game design for the delivery driver project. Why do we talk about game design? Well, I think it's really important to establish some general guidelines for what it is we're going to work on, and so you know how to make better decisions throughout the process. It's really, really useful to start with a gameplay overview screen like I've got here. It can be a very rough mock-up with little cubes and circles and what have you, just so you get a feel for your game and you can start to visualize how your game is going to play. So in our game, we need to have the player's car. We need to have some obstacles you can bump into. I'd like to have some speed-up things that allow me to go a little bit quicker. Also, we need to have some sort of packages that you pick up, and when you pick them up, they disappear. And then we have the customer or some sort of delivery spot that we have to deliver the package to. We're not looking for something super sophisticated, just the general mechanic of you can drive, speed up, pick up things, bump into things, and deliver to the customer. Now, if we look at the game mechanics that we need to build, we need to start thinking about what are we programming? What do we have to create as developers? Well, we need to have our car driving forwards, and I'd also like to have it driving backwards. We need to have the car able to turn left and to turn right, obviously. We want to be able to increase the speed of our car when we drive over speed ups and also decrease the speed of the car when we bump into slowdowns. We also need to have some sort of mechanism so we can pick up packages when we drive over them, and also some mechanism to deliver packages when we drive over the delivery spot. So in our code, we need a way to pick up and put down the packages. And also, I'd like to have within our code a way to change something about our game. And I think the color of the car is a good way to show the status of whether you have picked up the package or whether you've had to slow down or whether you're going fast. And just a simple change of the color, I think, will allow us to do that. I also like to cover three main things when I'm creating a game, particularly when we're creating these small games. I like to look at the player experience. Well, what is the player experience? This is the feeling you want your player to have when they're playing your game. For me, I'm looking for a relaxing feeling, just driving around, picking up things, going a little bit faster, a little bit slower. I'm not looking for an experience which might be, say, frantic or might be make the player feel clever or might make the player feel rushed or panicky. I'm not going for that. I'm just going for relaxing. So it's good for you to identify what's the feeling you want the player to have. And also just to jot down the core mechanic, for us it's really simple. You drive over pickups. That's our core mechanic. So you roll over these speed things to speed you up. You drive over packages. You drive over where the customer is. What's the game loop? Find and deliver all the packages to win the game. So I encourage you, whenever you're working on a new project, just to be thinking about these things. It's not a lot of work to jot down these three things, but once you start to build your project properly, you want to keep referring back to these and be consistent with it, particularly the player experience. Don't start off making a relaxing game, then halfway through say, oh, I'll make it frantic, and then decide you're going to make it a puzzle game. That will lead to a game that doesn't feel coherent. Okay, so there's not much to do in this lecture, except I do have a quick challenge for you. I'd like you to let us know in the forum discussions, and I've given you a link that you can click on to take you to the right spot. What is your player delivering? So for my game, what am I delivering? Well, I'm going to be delivering tasty donuts to game development instructors whose wives are currently out of the house and won't know that the game development instructor is eating junk food when he should actually be eating roasted kale or some other sort of appropriate for someone your age type of snack. So, you know, that might be a little bit too much to communicate to the player, but we'll give it a shot and see how it goes delivering tasty donuts for these poor, unfortunate people at home that are, well, you get the picture. So anyway, there's the challenge, there's a context for it. Take on that challenge. When you're done, when you've posted what you're delivering, jump into the next lecture and we'll continue on starting to create our project. Hello again. In this lecture, we are having a very high-level overview of what methods are, and we're just going to make a capsule spin around by using the transform.rotate method. Okay, let's get started. Hello and welcome. We're going to start this lecture off with a challenge right from the get-go. I want you to start a new 2D project in Unity. So open up Unity Hub, start yourself a new project, call it whatever you like. Mine will be called Delivery Driver, but you can call it whatever you like. And then once the project is open, I want you to add a capsule sprite, and that's going to be our car. And then I'd like you to create a C# script we'll call driver. And then I'd like for you to add the script to your capsule sprite as a component. So if you're not exactly sure how to do that, we covered that in the very first intro section, but it's a case of adding that to your sprite. And then last step, rename the capsule sprite to give your car a nifty name. Mine's going to be called Cruisy McDrive. You can call yours whatever you like. There's your challenge. Pause the video and then start the video again once you've completed those steps. Okie dokie, so I'm in Unity Hub, I'm going to click on New, I'm using 2021.1, etc. I'm going to click on 2D, rename my project to be called Delivery Driver, and repos Unity 2D, yep, that's exactly where I want it. Click the Create button, wait a moment, make myself a cup of tea, go for a walk around the block, and when I get back, Unity hopefully will be good and ready to go. Okay, welcome back. I had a nice little walk around the neighborhood, did some push-ups, and here I am ready to roll, a little bit out of breath, but good for action. I'm going to jump over into my hierarchy, right-click, and select 2D Object, Sprites, and find a capsule. I'll rename it right now, actually. I'm going to do the challenge a little bit out of order, like a rebel. What was he called? Cruisy McDrive. Kind of makes me want to eat fast food, but hopefully I'm not going to get sued. That's probably far enough away from copyright, I think, to be able to call it McDrive. What are we doing next? We're creating ourselves a script, so right-click down in the Assets area, create C# script. We will call this driver. Now the last step was to click on Cruisy McDrive and then drag over driver. I could have also clicked on add component and searched for driver in there. That would have done the same job. Now it's time for a little bit of theory. Okay, we're going to talk about methods. What are methods? Well, methods are also called functions. So you might hear a lot of people referring to them as functions. Technically they're methods, but they're kind of pretty much interchangeable, those two words, when it comes to the way that we're using it in Unity and C#. Methods execute blocks of code that makes our game do things. So methods do stuff, essentially, and we can use the methods already available in Unity that some hardworking programmer in Unity headquarters has created for us to use, or we can create our own methods, and we'll be doing plenty of both of these throughout the entire course. The other thing I want you to know in this very, very quick intro to methods is that we do creating and calling. So when we create a method, we're giving it a name and saying all the things that it should do. So a method might be make the thing move forward, make the thing turn around, and we also call a method. And that is when we are saying, do the things now, please. Let's jump back into our game, and I'm going to open up my driver script. Double click on that. That should open up Visual Studio Code. Just going to tidy things up a little bit here. Let's see, I'm going to full screen this actually and make it a little bit bigger. So while we're learning things, we're taking up the entire screen just for a moment. And you can see right at the very start, we've got our using. These are namespaces. We'll get to that later on, but basically it's saying, hey, you can use all of the things that are contained within here that the Unity engineers have given for us. We've got public class. Classes is a way of grouping similar things together. And within particular classes, we have particular methods we can execute. And then we get to the stars of the show, start and update. We also have in front of start, we have some comments in here. You can tell it's a comment because it's in green, but also it has the double forward slashes at the start. You can do any old comments you want here, double forward slash, and you can say, this is staff, yay. So that's a way to create comments, pretty handy. In this case, we don't need these particular comments. So I'm just going to delete them for the moment, just so we can keep this as clean as possible. But in general, I don't bother. I just leave them in there. Okay, so start and update. These are methods. In particular, they're callbacks. Now, we don't need to dig into the depth of what callbacks are, but what I'd like you to understand at the moment is Unity, the Unity engine and the Unity system of how it executes the game is going to call start and update a little bit in the black box. So somewhere Unity is saying, hey, do all the things in start. And it's saying, do all the things in update. Now, when does it call that? When does it say do all the things that start? It's just when we click on the play button. We click on play, boink, and then anything that's in start on any scripts that we have in our scene, it will execute. It will run and say, do these things now. And then we have update. Update is called, or update is happening, or update is doing its stuff, if you will, every single frame that our game is running. And we have lots of frames that are running every single second. So let's jump back into Unity and have a look at what we'd like to do here. Now I'm going to click on Cruzy, hit W to move Cruzy to the side, because I don't like that he's sitting right underneath the camera here. And what we're going to do in this lecture is rotate Cruzy using code. And if you have a look, we've played around this before. We've got our position, up, down, left, right. And we've also got our rotation. We want to be rotating on the Z or the Z axis. How do I know that? Well, I went to X and played around. I went to Y and played around. And went to Z, and I'm going to call it Z, and played around. And Z was the one who did it. The other way you can look at it is say, well, if we are rotating around this green, it's going to rotate around that way. If we're rotating around this red or rotate that way, Z is going into the world, and it's going to rotate around Z. How do I know it goes into the world? How can we see that? Well, a little sneaky trick for you here. Up in our scene window, you see a 2D button. If you click on that, it will toggle from 2D to 3D. I'm going to hold down Alt and my left mouse button, which will allow me to rotate around. And you can see that we have this Z or Z axis that's going into our world. And if we rotate around that, so I'm going to hit my E key, you can see I'm rotating on the blue, which rotates around the Z. And also just a little sneakiness that in Unity, 2D games are basically just 3D games where we lock the camera by clicking this 2D button here, and we are only moving things around on the X and the Y axes. Okay, the next thing I'll show you is at the moment, if I was to rotate Cruzy, rotate like this, my widget is staying at the world's Y up direction and the world's X direction. I'm going to undo that move. If I come up to the top here and see where it says global, if I click from global to local, now as I rotate, you'll see that the green arrow is staying forwards relative to our object. Because we've rotated the object around, the object says, well, my forwards is now this direction. If we rotate around a bit further, it says, oh, my forward is that direction. That's kind of handy concept for us to have, just so we can see which way our car is facing as we drive things around. So you can see I'm rotating things around here just by clicking and dragging, changing the number in here, if you will. Change it, say, 45. Boom, puts on 45-degree angle. How do we do that in code? Let's return it to 0. Jump back over into our script. And in here, I'm going to do this in code by using a method. Okay, which method? Well, this method is going to relate to the transform component. So I'm going to start by typing in transform with a lowercase t, dot, and now you see Visual Studio is saying to us, hey, here's a whole bunch of things that you get if you're trying to use something within the transform class. So this is a class, and we'll talk about classes more later on, but we're using the transform class. It's also relating to this transform component just here. So in transform component, we can do things to position, things to rotation, things to scale. We want to do something to the rotation, and there's a method that comes with Unity already, which is called rotate. So we type transform rotate, and methods need parentheses at the end of them. So these brackets, these round brackets, are called parentheses. So transform.rotate, and then at the end is a semicolon. Now that's pretty good, but it's missing something, because what it needs within these parentheses is it's saying, hey, how do you want me to rotate? What do you want me to do? So this particular method is asking for some arguments. It wants to know how much you're rotating, and it wants to know how much we're rotating on the X, the Y, and the Z. So in here, we'll say, well, for example, let's rotate nothing on the X, let's rotate nothing on the Y, and let's rotate, say, 45 on the Z. So that's us calling the rotate method that exists already in Unity and putting that within inside the start method, which Unity is calling all on its very own. It's saying, I'll do start when you push the play button, Rick, no worries. And so let's save this up. Make sure you save. You don't have a dot up here. You've got the X back into Unity. And to see this more clearly, I'm going to grab my game window, hold my left mouse button down, drag it over to the side so that we have the game window and the scene window open at the same time. That'll just allow us to see more things. Just realign it a little bit, move the cameras around a little bit, all good. Now when I click on play, what do we expect to have happen? Blonk, it's rotated 45 degrees, and you can see our value up here is 45. So I'm going to unclick play to stop proceedings. So now we've done that in start. That's cool. The other thing I want to show you is we can put this exact same thing into update, and update is getting called, like I said, every single frame. So let's highlight our transform.rotate. I'm going to Control X to cut that. I'm going to jump down into update. I'm going to Control V to paste that. And this now will be rotating 45 degrees every frame that our computer is able to calculate per second. Let's save that back over into Unity. Now, there's a little thing I want to show you here. It might be a little bit hidden on your game window, but if you drag your game window in and find stats, just click on stats, you'll see at the moment we're getting 743 frames per second. Well, I've got a pretty quick computer, but the computer's not really doing anything at the moment, so don't celebrate too much. Let's click on play, and we'll see what happens. Okay, whoa, it's out of control. It's spinning really quick. We have... I'll just pause. You can pause by the little pause button next to the play button. 337 frames per second that we are moving 45 degrees, which is obviously really, really quick and a bit quicker than we want to. So let's jump back over into our script and we'll change from 45 to 0.1. And because we've got a decimal place in here, and because this is a float, we need to put F at the end. So Unity knows, oh, it's a float, and it doesn't get it confused with something else. Now let's save back over into Unity, click on the play button, and now our object is moving at a more sensible pace, but we're using a method to make our object rotate around, which is super cool. I'm going to unplay. I'm going to click on stats to get rid of that, put my window back in a sensible position. Just a reminder here, we've played around with start, we've played around with update. Both of these are methods that are being called as callbacks by Unity, and we ourselves are calling the rotate method, and we're adding in these particular parameters to make our thing rotate around. So there we go. There's a quick introduction to methods. I will see you in the next lecture. In this lecture, we're adding another method. We're adding transform.translate so we can move our car forward. And by the end of this video, we'll have our car rotating around and moving forward at the same time. Let's get started. We used transform.rotate in the previous lecture to rotate our car. Now we're going to use transform.translate to move the car forward. We also need to provide the X, Y, and Z amounts we want to move, just like we did in rotate. Let me jump back to rotate over here by opening up my driver script. In rotate, we needed an X, a Y, and a Z value in there in terms of how much to rotate. We need to do the same for translate. And I'm going to give this to you as a challenge, but first I'm going to comment out our rotation so that we are only focusing on the translate for the moment. We'll uncomment this after we've done translate, but we're going to comment this out for the moment, and I want you as a challenge to make our car move forward. So in update, call transform.translate, just as we did with the rotate. We're going to do this with translate, and add the X, Y, and Z values you think we need to add in there so that our car slowly moves forward. There's a little bit of figuring out going on to do that, but pause the video, take on this challenge. I'll see you back here when you've given it your best shot. Okay, so let us add our new line, transform.translate. And you can see I get a couple of letters into it and Visual Studio Code saying, I think you might want translate. You can hit space or tab. I usually use tab to complete that word. It's a little bit handy to autocomplete. We need our parentheses. Okay, now we need to be adding in here the X, Y, and the Z as we did with our rotate. I'm not exactly sure what we need, so let's jump back over into Unity and have a look. If I scroll in, click on Cruisy McDrive, and you can see I want him to go forwards to drive up in the car direction. So if I move upwards, what's happening over here in our transform, you can see I'm translating on the Y axis. So I want the Y to be changing and moving in a positive direction. And that means that when I pop in here, the first one is X, the second one is Y, and the third one is Z. So I need 0, don't want to move any on the X, and then I'm going to put in here 1, and I think that might be a bit too big, but I'll put in anyway, and then 0, because I don't want to move any on the Z, and then the semicolon at the end. Let's save that. Let's look to see what happens here, and I kind of know a little bit what's going to happen, so I'm going to zoom my camera out a little bit, and then click on play. So every frame we're going to move way off the screen. We're going to move 1 on the Y-axis. So we'll jump back into here. As we did with rotate, we'll make this, I'm going to make it 0.01 F. Remember, if you're using decimal places, we want to pop an F down the end. Save that. We'll see if this is a little bit more of sensible movement. I'm going to click on play once we're finished doing all this compiling, and we should see slowly heading in a forward direction. Excellent, that's what we wanted to do. Now I'm going to do something a little bit tricky. I'll uncomment our rotate and save. Make sure you always save. Jump back over into Unity, and I'm going to move my car over to the right because I know already that when we rotate, we're going to be heading, rotating in a left. What's that? Left is anti-clockwise or counterclockwise direction. So when I click on play now, we're going to move forward a bit, rotate a bit, forward a bit, rotate a bit, forward a bit, rotate a bit. That's how we're going to drive around in this nifty kind of circle. So we've now added translate to move our vehicle forward on the y-axis, and we still have in our rotate there, and we're rotating around the z-axis to have our vehicle just going around and around in circles. Not much of a game just yet, but we're well on our way to adding player control so we can make a game. Good work. I'll see you in the next lecture. Hello again. In this lecture, we're going to be adding some variables so that we can play around with our numbers more easily and make our object change its behavior. So let's jump in and get started. So the problem we've got at the moment is that our car is going a fixed amount of speed and a fixed amount of rotation. What if we want to push down the accelerator and go faster or slower or turn left or turn right? We can't do that at the moment. That's because we've got these numbers hard-coded into our method. Instead of doing that, we want to use variables. And you can think of variables like boxes. They help us store, manipulate, and refer to information. So for example, here I've got this box. It's called hit points, and it has a value of 20 stored in it at the moment. Each variable has to have a name. The name here is hit points. Each variable contains data. Presently it's 20, it could be 0, it could be 1,000,000. And each variable is of a particular type. This is really important. The type here is whole numbers, and whole numbers are known as integers. So we would write this or declare this in our script as int. This is the type, int, as in integer, and then the name, hit points, and we use a lowercase letter first of all, like a lowercase h, and then uppercase for any other words that follow. So hit points, written like this, equals 20, and then semicolon. We put semicolon at the end of things to say we are done with this particular statement. So that is how we declare a variable, so declaring it as a variable called hit points of type int, and also how we assign a value to that variable or define a variable. The hit points is currently equal to 20. In terms of types, there's a few common types that we'll use. Int is for whole numbers, float is for fractional numbers up to 6 or 7 decimal places, double is for fractional numbers up to 15 decimal places. To be honest, I don't really use double ever, because for me 6 decimal places is usually plenty when it comes to the precision I need, but if you needed a ton more precision, you might use a double. Bool is for a true or false variable. So if you want to say this is true, do a thing, or if it's false, don't do a thing. Bools are very handy. And string is when we wish to have a sequence of characters that we print out exactly as we've typed them in. And strings require quotation marks in order to say this is what we would need to create. So let's look at those examples a bit more specifically. If we wanted to create a float called speed, then we would type in float speed equals, and then whatever the value we wanted it to be, in this case 3.8. And as we've talked about before, if you're using a float and you have a decimal place in here, you need to put an F at the end of it, mostly so that Unity knows, oh, it's a float and not a double. We put the F at the end there. And then with a bool, we have the name is alive equals true. So we could define it as true or as false. And then, for example, with a string, we would once again start off with the type string, and then we would give it a name. Here, I've given it my name, and my name is Rick. And once again, using our box analogy, the box is called name, and the information within that is Rick, which is just 4 characters, one after another in this particular sequence. So let's create ourselves a variable. Now, we need to put this in a specific spot. We want to put it within our class. These are all the things we're creating here within our class, but we put it above our start method. So we're declaring some variables right at the top here. I'm going to declare a variable which would be of type float. It's going to be a float because I need decimal places, and I will call this steer speed. I could call it steering speed or turn speed, any of those kind of things, but steer speed makes sense for me. Steer is what you do on the steering wheel. and speed is obviously how fast we're going to turn or how fast we're going to steer. And then equals, and I will initialize this, or in other words, give it the first value of the value that we've currently got down here at the moment, which is 0.1f, and then semicolon. Now what do we do? Well, we've got this steer speed variable. We pop that in here within our rotate method instead of using the actual value. Type in steer speed. And just to reiterate, the reason we're doing this and not leaving that number in there is because we want to change steer speed based upon things that happen in our game. So sometimes steer speed will be 0.1f, sometimes it'll be 0, sometimes it will be 1, for example. So we need to be able to change this, which we'll do in upcoming lectures. But if we just have a hard-coded number in there, we can't change it on the fly now, can we? Okay, so we've added steer speed, and I've got a challenge for you to make sure that you're following along to create a variable called move speed and to use that variable in your transform.translate method in a similar way to that which we've just done in our rotate method. So please pause the video, take on that challenge. See you back here when you're done. Rightio, so we will create ourselves a new variable, which will be of type float as well, and we'll call this move speed, and that will equal whatever we're using down here at the moment, 0.01f. And this is just where we're initializing it. This can change. This is just saying what the starting point is. And then instead of having our numbers baked in down here, we're going to add move speed as our variable, save that up, jump back over into Unity, make sure this all worked as a starting point. We'll click on play. The behavior should be exactly the same. Yes, it is. Fantastic. Okay. And then we'll do one last thing just to make sure that all works. Instead of having steer speed at 0.1f, let's make it, say, 1f. Now, just a side note, when you've got a float and you've got a whole number, you could just not put the f there, and Unity will say, that's cool, I'm okay with that, no errors in this instance. Or you can put the f there and say, that's fine as well. To be perfectly honest, sometimes I do an f, sometimes I don't do an f, depending upon whether I forget or I'm paying attention. So it's good habit to put an f when you've got values that relate to floats. So I'm going to leave the f in there, but sometimes you might see me accidentally not have the f, just so you know. Jump back over into Unity, click on play. What should we expect to see here? Well, we should expect to see that our thing spins around a lot more quickly. Zoom, zoom, zoom. There we go, still with the same forward, but more turning per frame. So that's the behavior we get. In the next lecture, I'll show you a way to be able to change those values right here from within Unity and not having to go back to your code each time if you want to change it. So I will see you in the next lecture. Hello again. In this lecture, we're doing something crazy. We're serializing our variables so that we can move our steer speed left and right within the inspector so we can see how our game is going to look when we properly implement our steering. So let's get started. Making your variables available in the inspector will save you a lot of time and also help a lot if you're working with someone on your team who maybe is wearing the design hat and doesn't want to dig around in the code to see what's going on. So what we're going to do is use something called serialized field. So if we jump back into driver.cs, I'm going to find move speed, give myself a space before that, use the open square braces, and you can see that Visual Studio Code has automatically added the closed, saying, I think you want to put something within here. I'm going to type in serialize field, and you can see I just type in SER and then it knows what the remainder is. You can click on that or hit tab or hit spacebar, and that will complete serialize field. And serialized field is an example of an attribute. These square braces, when we put it before a variable or a class or a method, shows that we're adding some sort of attribute to the thing that is following it. So serialized field is adding the attribute that allows us to serialize, in other words, write to disk, this particular variable. And when we do that, we can access it in the inspector. So I'm going to save, jump back into Unity, and you should see, give it a moment to think about things. Make sure you're clicked on your vehicle or your player. You can see on the driver script, now we have move speed, and the number in here will be whatever we initialized this at, which is cool. Now I'm going to change the move speed to say 0.03, and then click on play, and that should change my speed so I'm moving quicker in this loop. And then if I change it while I'm still in play mode to increase it, whoa, it goes way off the screen, goes really fast. So you can change it while it's in motion, which is pretty cool. I'm going to leave it at 0.03. Now, what I want to highlight here as well is as soon as you change this within the inspector, that will be the new value, despite the fact when I go back here into my code, it's been initialized at 0.01. This is being overwritten by the value that I'm saving to my disk, which says 0.03. So sometimes that can get you a little bit of confusion where you're looking in your code and you're saying, hang on a minute, 0.01, why is it going so fast? As soon as you modify the value in the inspector, that becomes the overriding value, and that's the one it's going to be using. Okay, so we've done that for move speed. Let's do that for steer speed, and this is time for a challenge for you. Serialize your steer speed. Using serialize field, make steer speed available in the inspector. And then I've got another kind of quirky challenge for you here. Drive your car using the inspector. See if you can keep it on the screen for 10 seconds by modifying the value of the steer speed while you are playing the game. There you go, take on that challenge. I'll see you back here when you're done. Okay, first step, we're going to put a serialized field in front of our steer speed. So serialized field, hit tab to autocomplete, click on save. Pretty straightforward to add that bit of code. Jump back over into Unity. It'll think for a second. We should now have a second value, which is steer speed. I'm going to pop my move speed down a little bit. I'm going to cheat a bit here. I'm going to make move speed 0.01, so we're going a little bit slower. I'm going to click on play. I'm going to get ready over steer speed. It's doing some lefts. I'm going to turn it to increase it. No, I need to decrease it so it doesn't turn as much, and then back the other way. That will turn it the other way. Okay, so we've got the fundamentals of steering our vehicle. It's a little bit clunky and not exactly how we'd want our player to play the game, but it is working and looks pretty cool. It's a car driving game, and we can do this by we're playing around with moving our steer speed in the inspector. And obviously the next step is for us to hook this up so the player can use keys on their keyboard, because obviously the player is not going to have access to the Unity inspector when they're playing around. But this is the fundamental. We've got move speed to go faster or slower. We've got steer speed to move left or right. So there we go. I'll see you in the next lecture. In this lecture, we're going to be changing things so that our player can push forward, move move backwards, and rotate left and right using the left and right arrow keys. So let's add input into our game. Let's start by understanding what an input system is. So an input system is a way of converting the player's physical action, so in other words, a button press or a key press, into information for the game so that it can understand it and know what to do with it. Unity has used a few different input systems over the years. They're constantly evolving and improving, and currently, in the version of Unity that I'm using, there is an old system and a new system, and it's actually called the old system and the new system. We're going to use both of these systems in this course, and I'm going to, in this current project, use the old system because I personally think the old system is a lot easier just to understand and to get started with and say, let's just make a thing happen, but we will use the new system later on in this course. Let's start that process of having a look at it. If you go up to Edit and then find Project Settings, you'll see a whole lot of settings in here. One of these is the Input Manager. You might have this closed up on your axes. So Input Manager, axes, and axes is the plural for the word axis, which is basically meaning from one side of something to another side of something. So that's an axis going from, say, 0 to 1 or -1 to +1. And all the steps along in between. So the axes that we've got in here, a whole bunch that are already within Unity. One is horizontal and another is vertical. So horizontal is going to be a way for us to push left or right and have our vehicle go left or right. Or you could also use A and D. So if you look at left and right, the arrows on your keyboard, well, A and D is also correspond to, if you say, using the WASD controls as you do in a first-person shooter, the A would be left and D would be to the right. And there's a couple other settings that come along with this, but mostly I'm going to leave those as the default, just knowing that we need to know the name horizontal, and we know that that's going to correspond to left and right. And also vertical, similarly, we need to know the name vertical, and that will correspond to up and down on the keyboard, or S and W. Interestingly, if you scroll down, you'll see that there's also another horizontal and vertical, round about here, horizontal, and this is going to correspond to using a joystick or a gamepad where you can do similar. You can move up on the joystick or down on the joystick, and likewise with vertical. So it's already set up within Unity that you can use keyboard and mouse, as well as joystick or joypad to be able to control. We're just going to worry about keyboard for the moment, just because I know that not everyone has a joystick that they have access to. Now, the one nasty thing of using the old system is that we need to get the name exact because we're going to use a string reference, and I'll show you that in a moment, but just remember, if you have any issues, it might be because you don't have the name typed out exactly. And the last thing I'll mention in here is that our horizontal and our vertical axes are going to go from -1 to +1. So from -1 through 0 to +1. So within rotate, we've currently got steer speed, which is cool, but I want to replace that, or I want to add to that, a way that we can access our input, access our horizontal input. So within our update method, this is going to be a little bit messy for a moment, but we'll tidy it up later on. I'm going to add myself a new variable, which will be of type float, and I'll call this steer amount equals, and you know what, we'll finish this in a moment because I first want to touch on the fact that, well, we've got a variable down here in our update method, whereas before we put our variables outside of the update method. What's going on with that? Well, there's a few reasons. The one important reason at the moment is I need to be able to calculate this steer amount every single frame because the player's going left and then going right and then doing nothing, and left and right and left and right. So I need to have that within update that we're calculating what is the steer amount, how much am I steering every single frame. Whereas these other variables, I only need to be knowing what they are at the start when I click on play, and I'm not changing them every single frame. So I don't need to put them down in update. So that's one of the reasons why we've put our variable down in here in update, because it needs to be updating and changing. Okay, so steer amount, and then here I'm going to call a method. Remember, we're calling methods here when we say transform.rotate, that's calling a method. I'm going to access input, and this is a class of things to do with input. So input dot, what do we have access to within the input class? Well, a bunch of things in here, one of which is going to be get axis. Get axis is going to get a particular axis. Which axis? Well, we add our parentheses, and here's where we put in a string reference. And string references are a bit yucky because if you spell them wrong, it doesn't work, and it often doesn't tell you why it didn't work. So we need to be careful here. We're steering, so we need to add horizontal, and make sure you type it exactly as I have done there, or you can jump back over into your edit, project settings, find horizontal, double click on that, Control C for copy, and then back over into your code and paste it straight up in here. So that's the way that you can make sure you don't mess it up. And then semicolon down the end as a starting point. We're going to add to this in a moment. So instead of steer speed, I'm going to add in here steer amount and see what happens. We'll update this in a moment. I just want to start. So we've got steer amount, which is basically just, hey, what's the player pushing from -1 to +1 on the left and right arrows? We'll save that, jump back over into Unity, click on play. Now we should have the first controls within our game. Click on play, left and right. Well, first thing I notice is it's back to front. It's backwards, but it's actually working. Working. Lovely, and it's not too bad. So I'm going to get out of the play mode, jump back over into here. I want it the other way around. So instead of having steer amount, I'm just going to say negative steer amount. Actually, I'll grab my pen tool and just quickly draw that on the screen so that makes sense here. So we're talking about steer amount, and if we have a value of -1, which is saying left, and +1, which is to the right, 0 is doing nothing. So this is left arrow and right arrow. If we push down the left arrow, we're going to get a value of -1, but currently that's making us rotate in the wrong direction. So just basic maths is if we say minus -1, that actually equals +1. -1 equals +1. And over here, if we were to say add a minus to this, then minus +1 is going to equal -1. So it's one of those rules that I think many of us know, but if you try to subtract a negative, then what you end up doing is actually adding. So if I try to say, for example, 0, take away -1 ends up actually saying 0 plus 1. Because when you take away a minus, you end up adding. And if that doesn't quite click for you, then you can just look at it from the point of view of saying, adding a minus will say, do the other thing, do the opposite. So instead of doing a minus, we'll do a plus. Instead of doing plus, we'll do a minus. That's another way you can look at it since it's doing this. So we're doing that. Steer amount is now heading in the direction we want it to head in, which is cool. However, we've lost a little bit of our control in terms of how fast we turn. So what I'm going to do in here, my input.getAxis, I'm going to multiply. So we use this asterisk, which is above 8 on your keyboard, multiply by steer speed. Now, whatever we put in steer speed, which is currently 1, but we might have changed it in our inspector, is going to be multiplied to the horizontal value, and we're going to be applying that as our rotation value in this Z part of our rotate method. Now, jump back over into Unity. So click on play, make sure I'm clicked into my game window. When I hit left and hit right, it's going the same speed it was going before because I've just added 1 into my steer speed. If I pop in here, say 0.5, click on save, click on play. Now have a look at what we're going to do in here. Start moving left. Okay, we're turning more slowly. So I now have the ability to read in the player's input on the left and the right, and also by multiplying that by 0.5, or the steer speed, I can change how fast my player is turning. I could put that up to, say, 3, and then click back in my game window. Whoop, I'm a little bit off the screen here. And then you rotate in a way that's super crazy and fast. Now, what you might have noticed there, I didn't mention this before, but if you're in play mode and you make a change to any of these variables, the values to the variable, then when you click out of play mode, it'll return back to what it was before. So if you make some cool changes, then you want to remember it or write it down, or you can also click on right click and copy, and then you can paste it back into the value that you had before. So this is what we've got for our rotate. It's steer amount, and we're using the horizontal times by steer speed. Your speed might be a little bit different to mine, and that is because of the speed with which your computer runs in order to get the same result. We're going to cover that in the next lecture, but for now we'll leave it as that nice basic formula just there. The other thing we need to do is to add the same sort of logic for movement. So we're taking in the vertical axis, and that's going to be your challenge. So use the vertical axis to allow the player to drive forward and backwards using the arrow keys. Just a little bit of a hint, you can add it as a line just here. Whatever new line you're going to add, you can add it just underneath the steer amount. And there's your challenge. Pause the video, take that on, see you back here when you're done. So hopefully that made sense, because we're going to do a very similar thing as what we just did to our steer amount. We're going to do for our move amount. So float, and then we'll call it move amount equals input.get axis parentheses, and then vertical. Make sure you spell it exactly like that, or else you'll get some issues. And then we're going to multiply it by what? We'll multiply it by move speed. And then we need to, instead of using move speed, we want to use move amount in here. Cool. We'll save that up, jump back over into Unity. I want to make sure that I can move forwards and backwards. This move amount multiplier, that'll be interesting to see if that is enough. So click on play. It shouldn't go anywhere when I click on play. Okay, good. Now when I push forward, it goes forward, backwards, backwards. And can I steer and move at the same time? Indeed I can. Wonderful. Excellent. So there we go. We've added input so our player can drive their car. I'll see you in the next lecture. So what's the problem that we'll get with our current code? Because we're saying in update, do a thing every single frame. If I'm on a fast computer, then it's going to do that a lot of times and maybe have my car move different to someone who's on a slower computer and they're doing things less per second. So we need to understand how to use time.delta time and what it is. Time.delta time is a way that Unity can tell us how long each frame took to execute. So on a fast computer, it's going to take a short amount of time for each frame. On a slow computer, it'll take a longer amount of time. And then when we multiply something by the amount of time it took for each frame, it allows us to make things frame rate independent. So in other words, the game behaves the same on fast computers as it will on slow computers, or if you're working on a mobile device versus a computer, etc. We want to make sure on everything we get the same sort of behavior. So let me give you a little example here if that hasn't clicked just yet. On update, so in other words, each frame, we want to move our player 1 unit to the left. So on a slow computer, we might be getting, say, 10 frames per second. On a fast computer, we might be getting, say, 100 frames per second. And it's going to vary, even on a fast computer. Sometimes it'll be 100 frames, sometimes it'll be 200 frames, some 150 frames, depending upon what else the computer needs to calculate. It bounces up and down, so we need to smooth all of that out. But looking at my example here, if we have 10 frames per second, that means each frame is 0.1 second, yes? 0.1, 0.1, 0.1. If you do that 10 times, it reaches 1 second. On a fast computer, if we've got 100 frames, then each frame is lasting 0.01 of a second, because 100 of the 0.01s is going to add up to 1 second. So the distance per second, remember we're saying move 1 to the left every single frame, so 1, and we're doing 10 frames per second. If we multiply by 0.1, in other words, how long is a frame, we get a value of 1. It'll move 1 to the left. If we're saying in a fast computer, 1 frame, and we're doing that 100 times per second, then we need to multiply that by 0.01 to continue to get our 1 unit. So that's just a little bit of an example of showing that when we multiply by this time.delta time, in other words, how long is each frame taking, we can end up with exactly the same value no matter how fast the computer is running. And so if I jump back over into my code here, I can find my steer amount and my move amount. The steer amount, I've got a value from -1 to +1, because it's on the horizontal axis, multiplying by the steer amount, which at the moment I think in my code I've got as 0.05. Yep. And then I'm finally going to multiply that by time, capital T, dot delta, small d, and then capital T, time dot delta time. It's as simple as that. So a really simple micro challenge for you here. Do the same for our move amount, times that by time dot delta time. Pretty easy. That's why I didn't give this to you as a challenge slide, time dot delta time. So now they're both frame rate independent. However, when we save this, jump back over into Unity, we're now going to be getting exactly the same behavior on all computers, but it's going to have messed up our tuning because we tuned it in a way where we weren't frame rate independent. So now when I move, I'm moving, but so slowly you can't even see it. So now we need to go in and change the steer speed and move speed so that our car drives properly. And this is what I'm going to give to you as a challenge. So, if you will, change your speed amounts in the inspector to have your car respond to input as you would like it to. So, in other words, to drive and steer at the right speed. Pause the video, take on that challenge now. Okay, so first thing I'm going to do is try increasing it a lot to say 100 and 100, just to see what happens there. I'm going to click on play, push forward or backwards, too fast on the movement, and not terrible on the steering. So I'm going to iterate while in play mode. I'm going to bring the steer speed down, say to 20. No, wrong one. I'm going to move the move speed down to 20 and then click back in the game window. Moving, not too bad. I think it's steering a little bit too slowly because it's taking a while to do a big arc like that. So I'm going to increase my steer speed to 200. Click back in the game window. Now as I drive around, it's not too bad. You know what? That's pretty good. I could have the steer speed a little bit more, I think, probably to 300. Want it to feel nice and snappy. Click back in the game window. Vroom, 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 vroom. Okay, yeah, now it's feeling kind of cool. So I need to remember these values, 320. Click out of play mode. I'll lose my values, but pretty easy. 320 are the two values that I came up with. You're welcome to come up with whatever values you want. You don't have to do the same as mine. Your game should feel the way you want your game to feel. And that is all for this lecture. We've added frame rate independence by using time.delta time. I'll see you in the next lecture. In this lecture, I'm going to be adding a second game object, and also we're going to be playing around with colliders and rigid bodies, so objects can bump into each other and use the Unity physics system to apply force to one another. So let's jump in and get started. Let's create ourselves something to bump into. So a little micro challenge for you here. Add a new sprite into our scene, which is a square or a circle. Okay, so over in our hierarchy, right-click, 2D object, sprite. I'm going to add a circle, I think, and then give us a chance to name it. I'll leave it as circle for the moment. I'm not exactly sure what it's going to be yet. I'm going to click on that circle, hit W, just move it over to the side. While we're here, we could also play around with the scaling of it, so I might do that. Hit R on the keyboard and just scale it up a little bit. Around about there. You know what? I'm just going to type in 2 tab 2 tab 2. When I say tab, I'm not typing tab. I'm just hitting tab to move to the next cell so that I can type in 222. There we go. We've got a 2-sized circle to bump into. I'm also going to change the color from within Sprite Renderer. You see color as a field. Click on the white space in there and change the color, circle thing around the outside, and then circle thing on the inside. It's kind of a yellowy, orangey color. There we go. So I'm going to click on play. We'll see what behavior we've got here at the moment. If I turn my vehicle towards the circle, drive over it, or towards it, I just kind of drive past it. Nothing happens. The circle doesn't move. There's no bumping into going on here. So what do we need to do to get these things to bump? At the moment, all we've got is a sprite renderer as the component on these game objects that says it looks a certain way. It's an image, basically. What we need to do is add two things. One of the things needs to go on both of these objects, and the other thing needs to go on only one object. Okay, so what are these two things? First of all, we need to add colliders. So we go onto our player, click on our player, then find down the bottom in the inspector, add component. I'm going to search for collider. We've got a whole bunch of options in here. Now pay close attention to the fact that some of them say 2D and some of them don't say 2D. The ones that don't say 2D is when we're working with a three-dimensional object, in other words, something that's not a sprite, but when we're working with sprites, as we are here, we want to be adding things that say 2D down the end. So what have I got here? Well, it's a capsule, so I'm going to look for a capsule collider 2D. click on that and then scroll right in so you can see this. You can see we've got our Capsule Collider 2D component. And what I'll do just for a moment is to turn off my sprite renderer so that we don't have our image anymore. And you can see we've got this green line around the outside. Now, the player never sees the green line, but Unity knows that this green line is collision. It's an invisible force field that we can have things touch, and when they touch, we can say what the behavior will be. For example, they bump off and go in a different direction, or they can't pass through. So this is when we have a collider. We're also going to talk about triggers in the next lecture. That's something slightly different where you say some things can pass through this collision area, but when it does, we want to send a message. We want to know that it passed through it. You know, you've entered the force field and something happens, or you've exited the force field, or you're still inside the force field. So there's a lot of things we can do in relation to this collision. So I'll turn Sprite Renderer back on, and then we'll jump over to our circle, and we'll do the same thing. So a little micro challenge for you again. Pause the video and add the appropriate sort of collider to your circle, or to your square if you added a square instead of a circle. Okay, so we click on circle, add component. My search that I put in before is still there, so collider, and because it's a circle, I'm going to add a circle collider 2D. If you added a square, then you would add a box collider 2D. And once again, it should conform nicely to the shape of the object that we have in there, which is really handy. So you can see there we go, we've got our collision. Okay, so we have collision now on the outside of our objects. That means that Unity knows, okay, what is going to bump into what? But there's one last step we need to do, and that is to add to at least one of these objects needs a rigid body. What is a rigid body? A rigid body is a way of saying this thing has substance, and it's the thing that the Unity physics engine understands that it's going to move around and it's going to be able to bump into and collide and have physics interactions. So let's scroll down. We'll click on our player, scroll down to add component, and we'll search for rigid body, find rigid body 2D, and add that. This now says the player, our Cruisy McDrive, can interact with things using the physics system in Unity. If we click on play, we'll see some behavior here that's quite interesting. Our object now just automatically drops off the screen. Why is that? Well, that's because we've got gravity on. So if we set gravity to 0, that means that this object is not going to have any gravity applied to it, and it's not going to drop off the screen. Why would we want gravity? Well, if we're making a side-scrolling platformer, we want to be able to jump and drop and jump and drop, and gravity is quite useful and quite important. But for us, we're making a top-down driving game, and there's no gravity that we can see. So now when I click on play, we see it doesn't go anywhere. And if I drive my vehicle, drive, and boom, it bounces into this and kind of gets flung out of the way. It's not actually moving the circle. We'll get to that in a second, but I can actually have this work with the collision. But it's a bit odd because I bounce into this thing and it's just staying there and not moving. That could be valid if you've got, say, a car and then you've got like a street post or a building or something that you don't want to have move. Like a car is not going to go and move a building. The building is going to stand there and say, nah, you didn't hurt me at all. But what if we wanted to move this object when we bumped into it? We wanted to have it respond a little bit. Well, this is a little micro challenge for you again. What can you add to our circle so that when the car bumps into it, it moves? We can add a rigid body to this object, to the circle. So add component, once again, rigid body 2D. And what do we need to do first? We need to change the gravity scale to 0. That's important so it doesn't go dropping off the screen. Now I'm going to click on play, turn my vehicle around, and boom, there's a little bit of a reaction. It's moving a little bit when we bump into it. It's not going flying off the screen, and that's all fine. But I'm finding it a little bit difficult to kind of push the object because I keep sliding off because we've got this precise collision on the front of our object. It's all very slidey, if you will. It's not hitting it tightly. What you could do, just going to unclick play, is click on our player, and then I'm just going to roll up a lot of these components. So if you click on the little arrow triangle thing here, I'm going to roll these up, roll up the sprite renderer. It's still there. It's just I'm not seeing all the details. It's a way of hiding it and making your inspector more clean and tidy. So roll up all these, roll up all these. There we go. It's a little bit tidier. I can see what I've got. And the Capsule Collider, I'm going to click the little checkbox that says, don't use this when we play the game. We're not using this anymore. It's still there, but we're just not using it. I'm going to add a component, which will be a collider, see a box collider 2D. Now when I look at my player, you can see that it's more of a straight edge at the front. So when I click on play, drive over to my circle, it's going to act a little bit more like a thing that can push, a bit more of a bulldozer, if you will. It's not going to give a very good effect when I do that. Like you can see, it's going to look odd for the player. So I'm using this a little bit sparingly, just for you and I now to see that that is another way that we could push a thing. Instead of having this capsule rounded thing at the front, we could have it as a square collider. And also showing you that you could change the collider. Now what I could do is for my capsule collider, I could right click and remove component, and we've deleted that. That's not there anymore. I've just got this box collider on my player. So it's pretty easy to add and remove colliders as your heart desires. So just to recap, we've added colliders to our two game objects so that they have the ability to understand when they're connected and touching and bumping into things. And we've also added rigid bodies to both of them so that they both have the ability to respond to our physics system. They can be moved around, they can interact, they can bump, and all those kind of good things. So there we go, a quick introduction to colliders and rigid bodies. Hello again. In this lecture, we're using onCollisionEnter within our code to know when we bump into something, and we can make our code do something. In this case, we're just printing to the console that one object bumped into another object. So let's jump in and get started. First thing we need to do in this process is create ourselves some code that says we know when things bumped into other things. And we're interested in saying, when did the player bump into anything else in the world? So I'm going to add a script to the player that says, let me know when I bumped into something. And basically, you could add all of this code into the one script you've got already. You could have a whole ton of different functionality in there, but that's bad practice because then you don't know what is going on. It makes this script really long. There's a lot to wade through. So it's better practice for each functionality that you need to make a new script. So let's right click in our assets area, create a C# script. I'm going to call this collision, hit enter, and then open up collision. From within here, we're not going to need start or update, so I'm going to highlight all of those things from the comment up above start all the way down to the second last curly brace you see in here, and delete that. So now we just have the open and the close curly braces that say, what would you like to have in this class that's called collision? Okay, we'll tab in one little bit just there, and I'm going to use another inbuilt method that Unity has similar to start and update. We've got something called onCollisionEnter, and we need the 2D version, just like in the last lecture where we were talking about sometimes we use non-2D, sometimes we use 2D. When we're working in a 2D project with sprites, we need to use the 2D version of things. And so I clicked on that to complete it, and we get a whole bunch of other stuff in here as part of the completion. So in general, I delete the word private from my methods. Basically, private is a way of saying this can only be used in this class. It can't be used somewhere else. We can't update or change or modify or call this from somewhere else. That's what private does. But if we remove the private keyword, it has exactly the same impact. So I remove it just to make things cleaner, but you could absolutely leave it there if you want, that private keyword. And now what I also do is I fix up my curly bracket there so that I have it nice and neatly aligned. You can totally leave it on the line that it's on like that. That's totally fine because white space doesn't matter in C# in Unity. So I could have it like that if I wanted to, because the compiler is just going to ignore all that stuff. It doesn't care about white space. We could have our lines like that. We could do it like this if we wanted. We could have a whole space in between there. I think you get the picture. Writing it like this is totally valid. It'll work, but it looks a little bit ugly, I think, and a little bit messy. So I'm just going to undo all these things. And for me, what I like is to have my curly braces formatted like this. So I do that anytime we get this kind of auto completion. I'll reformat it like that. And we also have some information that's being passed in collision 2D other. All you need to know for now is that if we bump into something, when we have a collision event, we can get information about the thing we bumped into. We can find its name, we can find details about it, we can change it if we want. So it's kind of cool. We don't actually need that for the little exercise we're doing now. So we could absolutely delete that. We don't need to have that information in there, but I'm going to leave that in, just undo. I'm going to leave it in there because there's no harm in having it. But I just want you to know that this does a thing. We just don't need to use that thing just yet. So I have a little challenge for you here. This is something that we did in the very first section of the course. We printed something to the console. So the challenge I've got for you is to print something to the console using debug.log. Print a witty message to the console when we collide with something. So pause the video, give that a go now. Okay, so we need to add this within our code block. So when we collide, we'll add something. We'll use debug.log, parentheses, and then quotation marks. What am I going to say? I'm just going to say, ouch. Is that witty? I don't know, but I think it's kind of funny myself. Ouch, semicolon, save. Now back over into Unity. So there's one last step in this process. Hopefully you figure this out when you're going through the challenge, but if not, what's the last step we need to do to print out to the console? Well, we need to click on our player and we need to add that script as a component. So I can do it a couple of ways. One, I can click in here, grab collision, drag it in, or I can click on add component and I can add collision. And you see our first one here is collision, the script. Click on that. We have a collision script as a component on our vehicle. Now we'll click on console again, and if we've set this up correctly, when I click on play, turn towards my object, charge, boink, and I bumped into it and it says ouch. And you can see here in the console, because we've got collapse turned on, we've got a number all the way over in the right hand side that says how many times we've called that and printed that to the console. So if I back up and bounce, back up and bounce, back up and bounce, you can see that the number is going up to 4 now. What I could do is unclick on collapse, and then every time I bump into it, it will make a new line in the console. I've kind of pushed him all the way off the screen. I'll see if I can push him back in again. Might need to cheat by looking at the scene window. Yep. Okay, push back into the world, and you can see it'll add a new line. If I click on collapse, it'll collapse it all so that we see how many's in there. Just a little trick there in terms of printing the console. It's really handy to use debug statements printing to the console when you're doing things, particularly with collision. So you know collision's actually working and you're not sitting there scratching your head because it's saying, yep, I bumped into a thing, which is really handy to do. So that's the fundamentals of using collision to make things happen in our game. I have a rigid body on at least one of these objects. In this case, we have a rigid body on both, but you need a rigid body on at least one. And we need to have our colliders on both of these objects. Both objects need to have collider. And now we can say when we bump into something, we can make our code do particular things. For the moment, we're just printing out to the console, but we can do more interesting things in the future when we bump into things within our world. So there we go. That's using onCollision enter within our game. I'll see you in the next lecture. In this lecture, we're looking at triggers and using onTrigger enter so that when the player crosses over a trigger volume, it will print something to the console. Let's get started. Okay, let's start this process by adding another game object that we can use as our trigger. So I want you to pause the video and add a box or something rectangular that we can use as a trigger. Okay, so in the hierarchy, right-click, 2D object, physics, and we will add a square. The square we will move a little bit above, or I'll move a little bit above, and I'm going to stretch it a little bit as well. Just hit R and stretch it a little bit that way. Change the color so we differentiate it. So clicking on my inspector, you can see that I've closed some things in here so it remembers I wanted it closed. I'm going to open that up again, the sprite renderer. Click on the white area, change this to a pink, I think, for our trigger. What do you think the next step in the process is? What do we need to add to this thing to know when we've passed through it, over it, around it? We need to add a collider. What sort of collider? We need to add a box collider 2D. That box collider 2D, as you can see, has taken the exact shape of our object, which is great. Now let's see what happens when we drive our vehicle towards that new thing we've added. If I can drive correctly, and we drive into it, bump. Okay, it doesn't move because there's no rigid body on it. That's fine. We don't need it to move, but we can bump into it. But what if I want to say this is like a start or finish line, or this is some sort of pickup I want to drive over, or some sort of indicator that says that the player passed from one zone to another. I don't want to bounce into it. I want to drive through it, but I still want to know when we've driven through it. There's one really simple thing. If we've clicked on our square just here, within our collider, you see is trigger. By clicking on that, we've now said that we want this collider to be a trigger sort of collider, Normally I wouldn't call it a trigger collider, I'd just call it a trigger, but you can see we've got a collider and we've said that collider is a trigger. Now when I click on play, I'm going to drive my car and my car is going to pass right over or through and not bumping into it, not getting stopped by it. Now why is it going underneath? Well, we talked about this in the first section of the course. It's because of our layer order. This square is at layer order 0 and our player is also at layer order 0, so it's a little bit random which one's going to be on top, which one's going to be below. I'd like the player to always be on top of these things, so I'm going to change the order in layer for the player, Cruising McDrive, to 10. Now when we drive over this, it should drive, and actually you'll see it driving over, there we go, over the object, which is cool. What's the next step? Well, we need to jump into our script, into our collision.cs script. Similarly to the way we said on collision enter, we're going to use a new method, which is on trigger enter 2D. And I'm going to give this to you as a challenge to see how well you've been paying attention. Print when we trigger something, so use on trigger enter 2D and debug.log to print yet another witty message to the console when we trigger something. So there's your challenge. Pause the video, take that on, test that it works, and I'll see you back here when you're done. Right, so in our code, I'm going to give myself a couple of new lines to give some space. I will type in on trigger enter, find the 2D version, and it adds in all this stuff as it did before. I'm just going to remove private because that's what I like to do and tidy up my curly braces. Now from within this area, I'm going to type debug.log, parentheses, quotation marks, and I will say, what was that? Not very witty once again, but I've got ouch when I bump into it, and what was that? Because the player has passed through something. Save, back over into Unity. Make sure we're on the console so we can see what's going on there. Click play, and we'll drive over the pink area, boom, and it says, what was that? The moment I pass into it. So you can see right about now, it increases my number in terms of my count, boom, just about there. And it only does it when we first touch it, the whole way passing through nothing, 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 and we leave. There's another method which is on trigger exit. If you want to know when someone leaves a particular area, you can use that method, but I'm going to boom, touch it, and then it will increase. The other thing you could do is you could click on your square and turn off the sprite renderer. So the player doesn't even know there's a thing there. I drive through it, I know it's there, you know it's there. That's our little secret, but see how my count is still increasing because I'm driving over that area. So that's the way that we can also use a trigger volume in a way that the player doesn't even know. So there's plenty of occasions in games where we want to say, did the player reach this point, or did something go off screen? If it did, then do something to it, or did I go into a particular zone? So triggers are super useful. And with that, my friend, you have the foundation of many games out there. You now know how to have the player go through a trigger volume and to have something happen in the code when that happens, and also for the player to bump into something and to have something happen in the code when that happens. So that really is the foundation of so many things that we do in our games, the triggers and colliders. So that's all for this lecture. I will see you in the next one. In this lecture, we're bringing in some assets into our game and just making sure they are all the right proportions in relation to one another. So let's get started. Let's start the process by bringing in the assets that I've given you, so you can find those in the resources, which is against this lecture, either to the right of the video or down the bottom of the video, depending upon where you're watching this, and you'll see a delivery driver assets downloadable file. So download that, and when you do, you'll see a zip file. What you need to do is to unzip that. On Windows, you go right-click, extract all, and you can unzip that. On Mac, you can go through a similar process for unzipping that. Once you do that, you'll see a folder which has some assets in it, some nifty cars and roads. Now, there's a really easy process when you're working with sprites like this. You can grab your folder and just drag it straight into your assets directory. Boom, and this entire folder will be brought in. You could do the same one asset at a time. So I could click here and just bring in the car, for example, and do that one at a time. But bringing in the whole folder, you should see that the delivery driver assets folder now exists within Unity. And interestingly, in some applications, it would keep the connection to wherever you downloaded that folder. So this car would be living at wherever you downloaded it. But within Unity, when you bring something in, you're importing it. So if I right click on this vehicle, show in Explorer, you'll see that this is now within my assets directory, which is in my repo, which is where my entire project is living. So it's now on my hard drive right with my project. Now, the first step in the process is we need to make sure that the things are of the same size. So if I drag a car into my scene, it will be this sort of size. It's a little bit larger than the car I was using before. That's fine. If I drag in a house, you'll see, oh, it's quite tiny. If I drag in a road, say this double piece of road, it's close. It's nearly where I want it to be for my vehicle. And there's a couple of ways for us to change the size of these. So obviously we could scale. So click on my scale tool or hit R on my keyboard, and then I can say, boop, 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 there we go, and we scale it. But that's a little bit inefficient because each time I drag one of these things in, I'm gonna have to scale that individual piece. So there's another way we can go about doing this, but first, I wanna give you a little bit of information about what we're doing with sprites and pixels in general, so you've got the context. And sprites are made up of pixels. They're an image, any image. So this image you see here on the screen, this font you see on the screen, the background you see on the screen, it has pixels. And pixel art is a type of art style, which basically means you just make the pixels very obvious. But in general, when you're working with an image, a JPEG, a bitmap, anything like that, it consists of pixels. And resolution refers to the number of pixels you have in an image. So high resolution means more pixels. If we use my little example here of a heart, you can see that it's an 8 by 8. So there's 64 pixels within my object here. 1, 2, 3, 4, 5, and so on. And pixels have a certain information. So this pixel is black, this pixel is red, and so on. Okay, so that's one piece of information I want you to understand. The next piece of information is that Unity has units, Unity units. And one Unity unit has no real meaning. It's just whatever we want it to represent. It could be meters or kilometers or miles or inches or whatever we want. So when you see in your transform, you see 3, 2, 0, that's saying we're at the position of 3 on the x-axis and 2 on the y-axis, but it's not saying 3 kilometers or 3 miles or 3 whatever. So when I scroll in here and have a look at my previous car, it's at position 6 and 0, 1 on the Y. So if I move this back to, say, 0, 0, 0, you can see that we have something that is touching the top of this grid line and the bottom of that grid line, which is a way of saying it's 2 Unity units in height. And if I move it over to the right, you'll see, most likely, it's 1 Unity unit to the left and to the right, so across the x-axis. So you see each of these squares here is 1 Unity unit. And so when you look at your game objects, you can say, well, is this house correct? Do I want my house to be whatever this is, kind of 3 Unity units? Maybe a Unity unit is a kilometer, but that makes this house gigantic, so far too big. Maybe, and what I normally think of a Unity unit is around a meter, just because that helps me. So when I look at this new car graphic that I've brought into my scene, if I click on it, you can see, just move it to a space just here, that it's around about 1.5, maybe nearly 2 Unity units wide, and around about 3 high, which is kind of similar to what a car is. A car would be around about 3 meters by 1.5 to 2 meters. So that's cool. I'm going to leave this car as it is and say everything else is going to work with the size of the car. So I need the house bigger. And so back to my information I was showing you here, we have something called pixels per unit. So a new asset will default to 100 pixels per Unity unit when we bring it in. So let's go and have a look at this original image. So remember here, this is the assets we're drawing from. This is on our hard drive, and then we can put a whole bunch of these into our scene. We're making copies or instances of these within our scene. I'll just undo all of those. But it's only living once right here. If I click on this car, then I can find my pixels per unit is 100 because it defaults at 100. That means that for every one of these Unity units, we have 100 pixels of my car. To show this even more clearly, here's my car. If I zoom in a whole bunch, this is in Photoshop. You don't need to worry about where this is. I just want to show you this because it's easier to illustrate. If I zoom all the way in, you can see that's a pixel, that's a pixel, that's a pixel, and so on. Zoom back out again, and this image is, we'll have a look at the image size. Image size is 182 wide by 354 high. That means that from left to right, we have 182 pixels. So you can count them up. You see these little gray and white squares up here, you could count those 1, 2, 3, 4, 5, and you would count 182 across and 300 and whatever it was wide. So jumping back into Unity, you can see, oh yeah, so if it's 182 from this mirror to this mirror, that's roughly just a little bit under 2 Unity units because we're saying 100 pixels per unit. So 100 pixels, and then we have another 82 pixels. Yes, that's around about what it is. So that's what we've brought it in as. So if I click on my house down the assets area, find pixels per unit, what we see on my slide here, if I want an image to be bigger, then I want less pixels per unit. Let me demonstrate that, and that'll, I think, make a bit more sense. So on here, if I say it's currently 100 pixels per unit, let's make it 50 pixels per unit, and then click all the way down the bottom. You might have this display in the way, or you might not. You can grab the little double lines there and push it out of the way, and then click Apply. that will make the house appear bigger. Now, it hasn't given it more pixels. There's the same number of pixels, but it's saying for every Unity unit of our image, we're going to use 50 of the pixels to fill that. If I was to make this, say, 200, it would take it the other way. I'll hit apply. That will make the house quite small. Where did it go? It's so small, I've lost it. Let's make sure it's not a layer order issue. Ah, yeah, it's sitting below the road. There it is. So I went the other way and increased the number of pixels on my original sprite image down here, pixels per unit, and that made it a lot smaller. Now it's saying, okay, we'll get 200 of these pixels into one Unity unit. I think 25 is going to be the right amount, which is another way of saying it's 4 times as large as when I first brought it into this world, and therefore it's going to be, what's that? Well, these larger lines are going to represent 10 Unity units. You can see the grids I've got on here. As you scroll out, different ones become darker. So it's going to be about a 10-meter house. Is that how big a house is? I don't actually know, but I think it's close enough. Okay, so we've got other cars, we've got other houses, we've got roads, rocks, and stuff. If we throw a few of these in, you see those trees are a bit too small. Those rocks, I'm not sure. That tree's a bit small, that tree. So what I want you to do as a challenge is set up the assets in your scene so that they look like the right size compared to each other. And a little hint, you can highlight multiple sprites and change their pixels per unit at the same time. So there you go, take on that challenge, and I'll see you back here when you're done. Okay, so I'm going to drop my other houses in there. It looks like they've got the same sort of proportion as our first one. Highlight both of those, and then find pixels per unit, 25. Click on apply. Blunk, that makes them roughly the right size for the houses. That's cool. 1, 2, 3. And then I'm going to click on my road piece. All of my road pieces, I believe, are going to look proportionate to each other. Yep, well, that's the same one I brought in before. That doesn't help, does it, Rick? Yep, that's the same. So I'm going to highlight all of my road pieces, shift and then highlight, and then I'm going to go control, 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 control. Well, I'm clicking, holding down control, clicking on the bridge, all the bits of road. What do I want to do? I'll make these a little bit bigger. So I'm going to say 75 pixels per unit. Apply there. So it has to go through all of these, think about it, and the one that we've got in the world looks like it's a little bit bigger now, which is cool. The rocks, I think, are good enough, and all of these trees, I get the feeling that they are all too small, so I'm going to make those 50 and see how that looks. Is that the right size? Tree versus car. You know, I want to make my trees much bigger, so I'm going to do these 25 as well. 25. Okay, that's a bigger sort of tree. And, you know, just to reiterate, once you've done that, you could get in there and scale it, make this one a little bit bigger, duplicate it, make another one a little bit smaller, so you've got some variation. Just because we make one of these 25 pixels per unit doesn't mean we can't then go and modify an individual game object that we've put into our world. Okay, so we've got our assets set up. In the next video, we might just lay out a little bit of a map to work with. So, great work in this lecture. I'll see you in the next one. In this lecture, we're going to lay out a simple level that we can drive our car around and give a little bit of meaning to our game world. First of all, when I click on play, I'm still driving around my capsule. We don't want that. Let us do a change so we drive around our car. Now, this is really simple. If you click on Cruisy McDrive, you'll see that under Sprite Renderer, we have the sprite. So it's saying, what visual representation do you want of this particular game object? If you click on the little target selector thing next to where it says capsule, then you'll see that we've got all of the sprites that we've just brought into our game. If you don't see them, you could always type in the search box for car, and then you'll see them listed out here, car 1, 2, 3. So I want you to select one of these cars, either 1 or 2 or 3. I'm going to use car 3 because I quite like it. Double click on that, and now when I click on play, I should be driving around, driving around a car. Cool. One thing you'll notice, though, is as I drive over here, if I get close to this thing that I should be bouncing into, it's like, oh, I don't bounce into it until I'm practically over the top of it, until my wheels are smacking into it. And so let's have a look at why that's happening. If I move my car a little bit down here, so I'm going to click on my other car and just delete that. That was just an image hanging out, whereas this is my game object that's driving. If I turn off the sprite renderer on and off, you can see that we've got our box collider is too small. So what can we do for that? Well, scroll in a bit so I can see. If you find the box collider, and just while I'm here, we started this capsule collider. I'm going to right click and remove component to delete that. I thought I did that before, but maybe I didn't. So we have our box collider. If you see where it says edit collider, click on the little button there. Now we've got some handles, these green dots down the end of our box here, and you can move them so that your collision box fits exactly where you want it to fit. So I'm going to put mine just slightly within the frame of my vehicle here. And then down to the end. There we go. Now our collision should allow us to bump into things more cleanly when we're driving around. So drive, drive, drive. Bonk. Okay. The other thing I'm going to do while I'm here just super quickly is click on the main camera and give ourselves a little bit more view, because we're a bit too close, aren't we? It's a bit hard to see what's going on in our world just here, too close to the car. So where you see it's under camera, it says size. That allows us to change the size, or in other words, change how close we look like we are to our world. So go ahead and make that whatever setting you want. You don't need to do the same as mine, but I'll probably make mine about 12, I think. Looks pretty good. Next, what we want to do is organize our hierarchy a little bit, so we don't just have a big old mess of stuff that we've popped in there. The way we do this is with empty game objects. So if you right-click in your hierarchy, click Create Empty, and you'll see it says Game Object highlighted. I'm going to type in here World Objects. You can call it whatever you want, world objects or environment or trees or what have you. Now, it's good practice to come over to the transform on this empty game object. It's an empty game object because there's nothing there. There's no components. It has a transform because everything has a transform, but there's nothing else to say what it is. It's just an empty thing. It's a container that allows us to do grouping and categorization, which is cool. So I'm going to right click on transform and just click on reset. That will reset it back to 0, 0, 0, just so I know that this empty game object is right in the middle of the world. Just one of those things. It doesn't matter a lot just yet, but it's a good practice because there'll be things in the future where you want to know that it's 0, 0, 0 for all of these aspects. Now I'm going to highlight all of my things that I've randomly dropped in there, the houses and the rocks and the trees and stuff, and I'm going to, after highlighting them, so shift and then click from one point, shift and then click, I'm going to hold down left mouse button and drag all of those on top of world objects, not below where you see the blue line or above, just right on top, boink, and that means that these are now childed underneath world objects. The world object is the parent and all these things are the children, and for now all we need to know is that means I can just roll that up and I don't have to see all that noise in my hierarchy. It also means if I click on world objects, for example, that will grab everything below that as well, and I can move everything around at the same time that's within that particular grouping of game objects, or as we would say, children underneath the parent. Okay, and while we're here, I've got 3 houses. I'm going to click on each of these 3 houses. So I click and then hold shift and then click again. You can see it highlighted them in the world and highlighted in our hierarchy. And then I'm going to come over and add component box collider 2D. Make sure you got the 2D down the end. And you'll see that puts a box or a collision around the outside of these houses. So if I try to drive through them, smash, I can't. I just bounce straight into them, which is cool. That's what we want. Probably want to do the same for anything you add into the world that needs some sort of collision. These trees we probably put around a circle 2D collider, I think, rather than putting a box collider, but we'll get to those in a moment after we've laid out our level and we've got stuff in there. So I just wanted to show you that step at this point. Now, what I want to do is to lay out a really basic level. So to drop down some road, make some bends and some what have you, put some trees and houses, just something really simple. You can go crazy on this after we've finished working through the project, but for now we don't want to over engineer this and spend too much time on it. You could, if you want things to snap nice and neatly, you could click, make sure you clicked on global and then click on the snapping mechanism next to it so it's highlighted, and that means that when you move around things they'll go click, 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 click and snap to each Unity unit. You can see over here it's going from -14, 15, 16, 17, and so on. I'm going to turn that off and just be fast and loose and just sort of slap things down and not worry so much if I've got little gaps in my roads. I'm not going to worry about precision yet, because who knows, once we've made our game, we might want to have a totally different layout. So the challenge I've got for you now is make a simple neighborhood that your delivery driver can drive around in. And as you do this, don't worry about if it doesn't fit within your game window. We're going to do something with the camera in upcoming lectures to make the camera follow the player. So take up as much space as you want when you do that, but don't over-engineer it, because we will potentially be changing things as we go. And then please do share a screenshot of what you come up with. So there you go, pause the video, take on that challenge. See you back here when you're done. Okay, I'm going to go through this really quickly. I'm going to rotate my first road piece. Actually, I'm going to delete that one. That's not the right one. I'm going to get one of these big roads, drop that into the scene, and I'm just going to speed up the video now here so you can see what I'm doing. I'm starting out by getting a general feel of where I want things to be placed. Just move the houses around a little bit. A lot of Control D to duplicate things like houses. Just make another one, make another one. I've dropped in some roundy kind of road pieces, and I'm like, you know what? A roundabout would make sense in the middle here. So I popped that down, adding some trees. I tried a square bit of road, but it didn't quite scale. So I popped in another roundabout in there just to get the symmetry going. A few more houses, a couple of trees, just a little bit of set dressing there to pop them around. It's good to scale, rotate, make them look a little bit different, so it doesn't look like you've just dropped the same thing down over and over, and just to get it a bit more interesting than just the roads. Okay, now let's do a little test run, make sure I can drive around my world, bump into things, bump, yep, some collision on that, bump, Drive, cool. Okay, so obviously we can't see our whole level. I can see it over in my scene view if I wanted to watch where my car is going. That's cool. We need to get our camera to follow our player around. There's a little basic level we can use. You know what? One last thing that's bugging me at the moment. I don't like that the background is blue, so I'm going to find my camera, click on main camera, change the background color to be a grass kind of color. So you're driving around, there's grass in the background. It's not amazing, but it's a little bit better than the blue, I think. And there we go. I've set myself up a basic little level we can use for the remainder of our project. Okay, hopefully you've done a great job on yours as well. I'd love to see it, so please do share a screenshot, and I'll see you in the next lecture. Hello again. In this lecture, we're setting up a follow camera so that we can drive our car around to all the different parts of our world. Let's get started. Just going to roll up my game objects here so it's a little less cluttered looking. Click on the main camera. You can see if we hit W to access our move tool, if we move around in our scene view, this is moving the location of the camera, you can see that this is how it will look if our camera is moving around as we drive. That's exactly what we want. What we want to do is say wherever the car is, say the car's over here at the position 13.5, then we also want the camera to be over that position at 13.5, so the car stays right in the middle of the screen. Now, just one little caveat, in the future we'll work with something called Cinemachine, which will give us another option for creating a follow camera, but for now I wanted to show you the way to do it with code so that you have that coding knowledge. Okay, so what we need to do is hop down into our assets directory, right click, create a C# script, and we're going to call this follow camera with uppercase F and uppercase C. Now let's open that up and we'll see, as always, we have the default start and update methods. All good so far. So let's ask ourselves, first of all, where are we going to put this script and what are we going to follow? Where we put the script is very important in terms of saying we are moving or changing or doing something to this particular thing. In this instance, we want to move the camera. So it's best to put the script on the camera because we're moving that. So that's the first thing. So we're going to say this particular thing's position is going to move around in the world, and its position is going to move around in the world to match this particular thing's position. So just undo those. So in here, I'm just going to write this as a note. Right at the top here, I'm going to say this thing's position, in other words, the camera, should be the same as the car's position, so that we know what we're doing in this script. And then I'll jump back over into Unity. And before I forget, because often I do, I'm going to click on the camera and then just drag the follow camera script onto the camera so we know it's there. The functionality is there. Well, I know I'm not going to need start because what we're going to be doing is going to be happening every single frame. So I'm going to remove start. I'm also going to remove this comment about what update does because we know that pretty much by now. In update, I'm going to put some code in here. Okay, we're going to start off by saying, what do we need to be accessing? Well, we need to access this particular game object, so this camera game object's transform and its position on the transform. So to do that, we start by typing transform dot, and then what are we accessing within there? We're accessing the position, so the value of the position. And we want to be changing that or updating that to be the same as the value of something else. Well, this is where we need to create a reference so that Unity knows what the heck we're talking about and what we're pointing at. Just a quick note on creating a reference, because we talk about creating references a lot. If we want to access or change or call or pretty much do anything to anything in our game other than this game object's transform, we need to create a reference. So just to make that really super clear, this game object is the camera because we put this on the camera. So this is the game object. The main camera is the game object. And we can access the transform because we get that for free. We don't need to go and make a reference to that. We don't need to point to that because it knows automatically, hey, if you're changing the position of something, I'm pretty sure you're changing the position of me. So that part's for free. That's cool. But everything else we need to create a reference to. So in other words, we need to tell Unity what the thing is that we're referring to. If we wanted to access this camera component, if we want to access the car, we want to access the house, the rocks, anything else, we need to say, I'm referencing this. I'm telling you I want to access this. So there's a bunch of ways to do this. We'll look at one in this particular instance, and that is creating a serialized field that we can point to in the inspector. So let's do this together. Start by creating a serialized field That means it's available in the inspector. We can see it in the inspector. And then it's going to be of type game object, because we want to be accessing the car game object, the whole thing, and saying where's it position. And we're going to call it, say, thing to follow, because we want the camera to follow this particular thing. Now, if I save that, jump back over into Unity, look at where we've got our camera follow script, and I'll just roll up a couple of these other components so they're not getting in the way, just camera. And you can see on our follow camera script, if I saved over here, did I save? So Unity's not happy with me because I was halfway through writing a line and then I sidetracked to tell you some theory. So I'm just going to comment out that line that I was halfway through writing, and Unity, I think, will calm down. They're like, okay, cool, Rick. Yes, now I'll let you do what you're trying to do. Okay, now you see on our follow camera, we have this thing to follow, and we've got a field just here. And by clicking on the little selector next to this, so just there, we can click on scene. This will show us all the things in our scene we have access to. And if I scroll around, I should be able to find Cruisy McDrive, double click on Cruisy McDrive, and now we have a reference. So we're saying, this is the thing I'm interested in. This is now stored within the variable called thing to follow. I could have also just dragged it from the scene, drag, and dragged it over into the box like that. That's another way that we could have created that reference. But now we're creating this reference to our player or to our vehicle. We jump back over into our script, and we can say, just uncomment my transform.position. What do we want this to be? Well, we want the position of the camera to equal the position of the thing to follow. And the way we write that is saying, let's first access the thing to follow, and then what do you think comes next? Thing to follow dot transform. Okay, what's the next bit on this? Position. And then we do semicolon and save. Now, I know that this is not quite going to work, but I'll show you what's going to happen here. When I click on play, the camera position will be exactly the same as the car position. So we'll click on play. Look what happens over here in our thing. It goes green, and that's a case of, what? Why is it doing that? Well, while we're still in play mode, I'll click on the 2D button over in my scene view, scroll around, see if I can find my camera. So double click on the camera, and you can see it's literally exactly the same place as the player, but that's no good because it means it's right on top of it. We need some distance. We need to be able to push it forward or push it backwards. And it won't let me do this in play mode because it's saying, no, you told me to be right on top of the car, and I'm right on top of the car. So we need to give ourselves a little offset. And you can see when we're not in play mode that the camera is back a little bit. And it doesn't matter how close or how far, when we're in this 2D view, it's going to keep exactly the same position. But if we go too close, boink, then all we're going to see is the background, and we're not actually going to see our scene. So what do we need to do? Well, we need to say, follow the position of the car exactly, but stay back a little bit on the, what's this over here, on the Z axis. So move back a little bit on the Z axis. And the way we do that is just by saying, go to the exact position of the car plus a little bit extra on Z. Or in this case, you can see it's minus that's changing as I push it further away from the car. It's the minus direction. So we're going to say minus, I'm just going to say 10 for now because that seems an okay spot. So just go to the car minus 10 on the Z axis. How do we do that? Well, we've got our formula here. And if we mouse over position, we can see that position is a vector 3. So we can't just get there and say plus minus 10, or in this case, it'd be minus 10. It's like, I don't know, what on earth you're talking about here, Rick? We also can't say plus, let's see, 0 on the X, 0 on the Y, and minus 10 on the Z. It's also saying, what are these numbers? You've got to help me out here. So there's a way we can do this by saying we want to add a vector 3, which is X, Y, and Z, sort of vector 3 is, into our current vector 3. And to do that, we need to use the new keyword and then type vector 3 so that Unity knows, oh, okay, you want me to add something that's a vector 3 to this. What do you want to add? And in here, we can say 0, 0, minus 10. And of course, those clever cookies of you would realize that we can also say minus plus 10. But for me, because I'm moving the camera minus 10 on the Z-axis, it makes sense to leave the minus 10 just in here. And normally I'd say don't have any numbers right down in the middle of your code, because if you need to change something, it's going to take a while to find this number and know what's going on. But I'm very, very confident that we're never, ever going to change this number just here. It's fixed, it's done, so I'm going to leave it forever. So I'm okay leaving this down in the middle of the code and forgetting about it. But like I say, if this was information that you might want to change at some point, then we'd need to create a variable and store that as a variable and do that a slightly different way. But we're not going to do that for the moment because we don't need to. So let's go have a look at what's going on in our game here. I've still left everything in 3D mode in the scene so we can see what's happening. Click on play, drive around, and you can see that we're being followed around. And we've got our nice distance of -10 on the Z-axis. We're staying away from the car, so it's perfect. I'm just going to get out of play mode, pop that back into 2D. There's one last thing I'm going to do in here. You might not be seeing any issues just yet, but we could get some issues with our camera being jittery, and we probably will in the future as we add more stuff in here. And that's because we will get a little bit of a conflict where the game says, I'm going to move the camera and I'm going to move the car, but sometimes I'll move the camera a little bit slower than the car or a little bit earlier than the car, because we haven't said specifically exactly when it should happen. So this brings me to an opportunity to talk to you about the Unity execution order. And what that is all of the things that Unity does when we push play and then on every single frame that our game is running. There's a lot going on, a lot we don't need to know about that's happening behind the scenes, but we know we've already played around with the start method or the start function. When we click play, this is part of the initialization, in other words, starting things happening. There's also another method we could be calling called awake. This is another callback that happens even before start. So if you need something to happen in the very instance, the very first thing that happens, awake is going to be better than start, but generally start is okay for us. And then we have our physics loop. So again, you don't need to understand all the aspects of this, but just know that physics is being calculated at a different rate to a lot of the other things in our game, such as our game logic. Physics is fixed. And the reason it's fixed is so that there can be predictability with physics. If physics was calculated too much, it might be too intensive for the game. So physics often requires a lot of calculations. So within Unity, physics runs with its own loop, and update can be a little bit different sometimes. Okay, and then what we also see within the general update, so here's our update here. This is happening on every frame, and we get more frames on a faster computer and less frames on a slower computer, but it's still running through update. And we have in here something called late update, which means with this whole update cycle, all the things that are happening on update each frame, we can say, actually, you know what, do this as the very last thing that happens in the game logic, the very last update thing. And then there's a few other things in here that we'll explore throughout this course, but for the moment, we don't need to look at all these various things, just to get the concept that there's a lot of things going on and they can happen at slightly different times. So we jump back in here, instead of placing our camera movement in update, if we place it in late update, which is just a case of popping in late in front of update, and that will change this whole thing from update to late update. Now we can guarantee that our camera will absolutely follow our car smoothly, because we know it's not going to be fighting with the car in terms of what's my position and where are you and where am I. Let's just check this works. I'll look a little bit silly if it doesn't work, won't I? Click on play. Okay, and as we drive around, that should be nice. Whoop, unless I bump into a tree, should be nice and smooth because we now have things in late update. Okay, cool. So that's what I wanted to show you. I wanted to get the camera working and just have a little bit of a conversation about the Unity execution order, specifically that we need to put our camera in late update so we don't have the jitteriness. Great work. I'll see you in the next lecture. In this lecture, we're working with if statements and tags so that if we drive over something that is tagged as customer, we print to the console, package picked up, and if we drive over something tagged as customer, we say package delivered. So let's get started. Let's start by doing a little bit of repurposing. I'm going to click on my object here that was just called square, and I'm going to rename this to be package. So this is now the package we're picking up, and just reshape it a little bit. So there we go. It's a bit of a square package. Doesn't quite look like the thing Amazon would deliver, but there we go. We'll pop it somewhere in our world so we can drive over it, put over near the player so it's nice and quick to find. Excellent. That's step one. Now, step two, I'm going to be using my collision script because that's what we've been dealing with on trigger enter and on collision enter, but collision doesn't make sense anymore. So I want to show you how we rename a script because it can be a little bit messy. First of all, I'm going to click on where it says collision one more time, or you can hit F2. Let me just check that works. Yep, F2. Instead of collision, I'm going to name this delivery because that makes more sense. We're dealing with the delivery system. So I'm going to hit enter. Now I'm going to open up delivery. You can see here it's still public class collision. So it thinks I'm a collision class. We're going to just highlight the word collision and change that to the word delivery, making sure we spell it exactly the same as the name of our .cs file. I'm going to save now back over into Unity. And the last step is to click on Cruisy McDrive, and we can see here that the delivery script has automatically been updated from collision to delivery. Cool, so that should all work exactly the way we want to. Now, let me tell you a little bit about the logic of what we're going to do. I'm going to show you what happens when we drive over, so when we trigger something to happen by driving over our package. I'm going to show you that, and I'm going to print out to the console a message that says something like you picked up the package. But we only want to print that to the console if it's the package that we drive over, because I'm going to give you a challenge later on in this lecture where I challenge you to make the customer, and if we drive over the customer, we want to print a different message. So we can't just say, when you collide with anything, let's just have a look at our delivery script. It says, when you collide with anything or when you trigger anything, do a particular thing. But it's like, okay, well, when we have on trigger enter with one thing, we want to do one thing. But if it's on trigger enter with something else, we want to do something else. How do we do that? The way we do that is with if statements. Let's talk about if statements just briefly here. So an if statement lets us check if something is true or not, and then do something based upon the result. And then this is how the syntax looks in C#. We start with the if keyword, and then in parentheses, we have the thing that we want to know if it's true or not. So we need to write something in there saying, is this particular thing true? And then in our code block, we have what it is that we want to have happen if that thing actually is true. So for example, for me, it might be if I'm hungry right now, then eat junk food while my wife isn't watching. That could be my if statement. You can tell what's on my mind at the moment. And if I'm hungry turns out to be false, then we don't even consider what's in the statement here. We don't even think about sneaking some tasty donuts while the wife isn't watching. It's a way of saying, if I'm hungry, do this. Otherwise, do nothing. Okay, so let's start this process in here. Now, I'll leave my on collision enter in there just in case we need it in the future, in case we bump into something, we might want to do something with that. But we're focusing the on trigger enter because we've got triggers. We don't want to bounce into the package and the customer. We're just trying to drive over them. So in here, we need to start our if statement. And I'm just going to put a comment in here and write some pseudocode because we don't have everything we need yet to execute on this, but we'll write the general meaning of what we're doing. So if the thing we trigger is the package, then what do we want to do? Then print package picked up to the console. Now we can give this a little bit more structure by saying we'd have our curly braces, and then we would have our print statement, and then we would have our other curly braces. All of these are within the comments. You don't need to be typing this. I just want to type this so you can see exactly what we're doing. And the bit that we don't have is, how do we know if it's a package or not? So let's have a chat about tags. Tags allow us to easily check in our code if something belongs to a particular category of thing, and allows us to speed up that process of saying, are you the package, are you the package, are you the package? So I'll show you how we go about doing that. We have our package, we're clicked on this game object, and over in the top right of the inspector, you'll see tag untagged. At the moment, it doesn't have a tag. It's like, I don't know what sort of tag you want me to be. No worries. When we click on the untagged area, we've got some default tags that already exist in Unity. Player is probably the main one that we would use in the future. But for now, we're going to click on the add tag, and then you'll see under tags, list is empty. Click the plus button. In here, I'm going to type package as the tag, uppercase P, and then click on save. Now we have package. That hasn't assigned it yet. What you need to do is click on the game object again. You see it's untagged. Now I can go and select package, and we've tagged this game object as being of tag package. It's not of type package. It's just been tagged as package. Now we can jump back into our code. And before I get rid of the comments, there's one other thing I want to show you in here. We talked about this when we talked about the collision and the trigger, that you can see we're accessing, or something's being passed into this. When it's called, it's being passed in. It's giving us information about the other thing that we bumped into. So this is really cool. This delivery script is on our car, but when we trigger something or when we bump into something with collision, we know what it is that we bumped into. So we can gather information from that. And in this case, we're going to say the other thing that we collided with, does that have a tag on it that says package? So that's what we'll do. We'll get rid of our comments here. We don't need those anymore. Thanks very much, comments. Lots of squiggly lines. Cool. If we're going to access the other thing we bumped into by typing other dot, and then it's as simple as saying tag. Then we're going to use the double equal sign operator, which is a way of comparing the left and the right and saying, are these two things the same? So we'd say equals equals, and then we're going to write in here, quotation marks, capital P, package, if I can spell it correctly. And this, as soon as we use the equals equals operator, it's going to say, is it true or not? Does the left equal the right? We get a true or false value back from that. So this is going to say it's either true, yep, it's a package, or the tag is not a package. And then in here, what do we want to do? Well, we will type in debug.log package picked semicolon, and save. Now let's jump back over into our game, click on the console so that we can see if this is actually going to work or not. Click on play, drive our car over to the package. Beep, 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 beep. And it says package picked up. Excellent. If you drive over it and over it, it's going to go up and up and up and up and up and up. So that's something we'll deal with in the future, where we get rid of the package after we've picked it up. But for now, we can print out the message that we've picked up the package. So I've got a challenge for you. It's going to be a little bit more detailed, but I think you're ready for it. It's to set up our delivery location. So I'm going to call it the customer. It's probably just going to be a box or a circle or something. It doesn't actually need to look like the customer because we're going to drive over it. But I want you to create a customer that allows us to print delivered package to the console if we drive over it, similar to the way that we drove over our package. Now, if that's enough for you to go on, pause the video and jump in and take that on now. Otherwise, I've got some hints for you. So if you don't need the hints, pause the video. But if you would like the hints, here they are. Create a game object that has a collider on it. If you can't see the object, check your sorting layer to make sure it's above the road. Set is trigger to true on the collider. Create a customer tag, as we did with the package tag, and assign it to the object, and then print your message if we touch the customer object. So there you go. There's your challenge. Pause the video. I'll see you back here when you're done. Okay, first step is get out of play mode. That's a good first step. And then right click, I'm going to create a 2D object. We'll make a sprite. What should we make this? You know, I'll make this a square as well. I'll just change its color. So we'll pop the customer over here. I'm going to increase the size of this a little bit. Just hit R and then grab the middle of it and scale it up for now. So it's nice and easy to see. We can change the graphics on this later on pretty easily. Change the color to maybe a blue. Now I'll rename this game object to be customer. Hit enter. I also need to create a tag. So click on tag, add a new tag, click on plus, and we will name this customer. Click on save. Now back to clicking on customer, the game object, and tag this as customer the tag. Excellent. Now we need to go into our code. I think we've done all of this. We're going to create another if statement. So a second if statement, which will be if other.tag equals customer. Then what do we want to do? Put in our curly braces, debug.log package delivered, semicolon, and then save. Now, I usually miss a step in these things, so let's see if I did or didn't miss a step. I'm going to click on play. Drive over here. Yep, package picked up, drive over here. Okay, so I have missed a step, and I know what it is straight away because I've missed this step many times in my career. Do you know what it is? What has Rick done wrong? What mistake have I done? If I click on customer, I don't have a collision on here. How do I know I've bumped into it? So I'm going to add a box collider 2D, and then the very last step is to make sure that I click on is trigger, and then save. Now click on play. That should have got it. So drive over that one. Good. And then over this one. Excellent. Package delivered. Cool. So now we've got the fundamentals in our code of it knows, oh yeah, you went over a package and oh yeah, you delivered it to the customer. So excellent. So that's all for this lecture. I will see you in the next one. In this video, we're going to fix a situation where the player could drive straight over to the customer and deliver the package, but they didn't actually ever pick up the package. So we want to make sure you can only deliver the package if you actually have the package. How do we do that? Well, we're going to do that using a bool. What is a bool, I hear you ask? Well, bools are types of variables that can store one of two values, either true or false. And they're often used with if statements to decide whether something happens or not. So if something's true, do the thing. If it's false, don't do the thing. So bools are very handy from that point of view. And in our code, we're going to jump back over into our delivery.cs script. Right up the top, up above our on collision enter, right up here, we're going to create ourselves a variable which will be of type bool, and we'll call this has package. You want to make sure that you name your bools in a way that it's clear that it's either true or false. Has package, it's true, or has package is false. If you just name this, for example, package, what does that mean? Doesn't make sense. Does it mean it's a big package or small package or red package or blue package? But if we say has package, then that's do I have it or not? And we'll do semicolon here. Now, we didn't actually assign a value to it, so we could assign it false to say we're pretty sure when the player starts the game it's going to be false, or we could assign it as true. Oh, when you start, you've got the package, it's true. But just a little experiment here. If we don't assign it anything, what will it be? How do we know? Well, we could go and Google the answer. What do bools default for in Unity, or we can do ourselves just a little quick experiment. We'll add start, I'll delete this again in a moment, add start, and we'll debug.log, and in our parentheses, we'll just type has package, and then semicolon. So what that will do when we first start our game, it'll just print out whether has package is true or false. So we'll save that back over into Unity. We'll just do this as a little thought experiment. I also want to get you in the habit of printing things to the console so you know what's going on. You're constantly testing and looking and not getting sideswiped by these things. So it starts off as false. So we know for sure this starts off as false. That means that we won't be able to deliver the package until we actually go and get the package. So how do we get the package? Well, in our onTriggerEnter, we've got if the other tag is package, then we want to pick it up. What would we do in this instance? After we pick it up, we want to change our bool to be something. We want to change it to be has package equals what? Equals true. So the logic here is if we bump into something that is the package, now the has package bool or the has package variable will be true. Excellent. When we bump into the customer, we need a way of saying, okay, the other tag has to be the customer, and you actually need to have the package, my friend, or else I'm not going to accept delivery. And the way we can do that is in our if statement, we can have multiple things we're checking to see whether they're true or not. So we can be saying, is it the customer? And then we can use the double ampersand. That's what that little symbol is called, ampersand, or it's called the and sign. So you do two ands back to back. That's the and operator. And then we're going to type in simply has package. We don't need to say has package equals true. You could do that, but you don't need to, because when you just add in the variable in here, it's going to say, okay, it's a bool. If it's true, do the thing. If it's false, don't do the thing. So let's save that and see if that actually works. We'll do, first of all, by driving over our customer and see what message we get. Make sure we don't accidentally pick up the package. Drive. What happens here? Nothing gets printed. The customer's like, well, unless we bump into the house and it says, ouch. The customer's like, nah, man, I don't know what you're talking about. We go over, we get the package. Now we've got the package picked up. Drive back over to the customer, and yes, package delivered. Excellente. However, what's going on here? Oh, I can keep delivering the package. I'll deliver it another time and get, sweet bonus and, commission and another commission. Okay, so we need to do something so that we can't keep doing that. We can't exploit that, because your players absolutely will exploit that. So little challenge for you here. I don't have a slide, but the challenge is add some logic to make sure that we can't deliver the package over and over. So what do you think we would do? Pause the video and have a go at that. So in our logic, we need to say once we've delivered the package, then we don't have the package anymore. So has package is going to equal false. And let's just check that that works before we celebrate too much. Click on play. We'll go through this standard process. We'll make sure that we can't deliver it until we have it. No, we can't. We'll grab it, and then we'll bump into a tree. Then we'll deliver it. Yes, package delivered. And then is it going up? No, the number doesn't go up. But if we go back over, we grab the package again, and then drive back over, it does go up exactly as we wanted to do. So there we go. We've used a bool in conjunction with our if statement to make sure that we can only deliver the package if we have the package. Okay, I'll see you in the next lecture. In this lecture, we're setting it up so you can pick up the package, it disappears, you can't pick up another package until you deliver that package, then after you deliver that, you can go pick up the next package, and so on. So let's get started. First step, we need to create a couple of extra packages to deliver and scatter them around our map. So I'm going to click on a package, Control D to duplicate, and then move that to a different spot over here, and then Control D one more time and pop that over here as well. Not trying to hide them too much yet. We're still in the prototyping phase. Side note, I think this circle, we don't need that anymore, so I'm going to delete that. So I have 3 packages floating around in our scene for us to drive over. And if I click on one of these objects, if I want to hide this, I've got a few options. First of all, I could just disable the entire object, so it just goes away. And that's one thing we can do. That's totally fine. I could also just turn off the sprite renderer, but then I'd probably also have to turn off the box collider. So these are things that we can do as well. We can access these components and say, do the equivalent of what I'm doing here, which is turning the checkbox on and off. However, for me, I don't want to use this package ever again. Once I drive over it, I consider that it's been picked up and it's never going to appear in the game ever again. I want to do the equivalent of hitting delete and getting rid of that entire thing so it's no longer sitting just there. I'm going to undo that delete. And to do that, we can use destroy. And I want to show you destroy because destroy is a handy thing to know how to actually delete something from your scene. And to destroy game objects, we call destroy. So we call destroy specifically to delete a game object from our scene. Destroy, when we call it, requires us to tell it, in other words, pass in two things. And we pass those things in to these parentheses. So we have to tell it something. What do we need to tell it? We need to tell it which game object to destroy and how much time to wait until it is destroyed. Now, it's actually optional to pass in the delay. If you don't have anything in there, then it will just destroy immediately. But for the purpose of this challenge, I'd like for you to put in both the game object and the amount of time you would like to pause until it is destroyed. And so in our case, where we're looking to destroy something other than us, we would need to type destroy and then in parentheses the monster or whatever the particular thing is that we want to destroy dot game object. So we need to say it's the game object we're interested in, comma, and then the delay. So in this case, I'm saying 0.05f. Now, before I give you a challenge, I'll give you one or two other clues in here. So we need to destroy the package after we pick it up. So we'll need to destroy it in a particular place. And also, what are we destroying? Well, the clue I'll give you is that this other is the game object. So when we're getting the information, it's telling us the other thing. It's starting off saying, here's the game object. In other words, we'll call it other. We'll name the game object that you bumped into other. So there's a couple of hints for you. Here's the challenge. So destroy each package that you run over after 1 second. Only destroy the one that you run over. Don't destroy all of them. But after you run over it, use destroy to remove that package so that we can pick them up and not have them in the game anymore. And I'd also like you to set up a variable and use serialized fields so that we can tune in the inspector how long the delay is before the package disappears. We don't need to go and find it in the code. We can do that from in the inspector and say half a second or 2 seconds, and we can shoot it from there. So there you go. There's your challenge. Take that on, and I'll see you back here when you're done. Okay, so where do we need to destroy? We need to destroy after we've gone and picked up the package. Then we say, get rid of that package. So I'm going to give myself a new line, destroy in parentheses. I need to access other because that's the other thing we're interested in. But I need to access the game object. You see, the very first property we can get at here is game object. So game object, that's the thing I'm destroying because destroy wants to know the game object. And then comma, I can type in 0.5f. And then semicolon. However, I challenge you not to have this magic number, to serialize a variable. So I'm going to jump up the top of my class, just above bool, serialize field, and then it'll be of type what? It's type float. We know that because there's an F down the end, but if we mouse over here, it's looking for, destroy's looking for a float T. You can see just in here, gives you a hint, object, and then float. So we'll add a float and we'll call this destroy delay. And I'm going to initialize that at 0.5f. So I'm going to give it a starting value. It'll be at 0.5f. Then down here, instead of 0.5f, I will call this destroy delay. Now let's save that back over into Unity. We'll make sure everything's hooked up the way we expect it to. If we click on Cruisy McDrive, we'll see, let's see, where is it down the bottom here? We have a destroy delay, currently on 0.5. If I click on play, drive over. Boop, 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 boop. Yes, after we touched it, there was a little bit of a delay, then it disappeared. What happens with this one? Yep, it delays as well. So they're all set up with that delay. This is a good thing just for me to note briefly, is that once you change something on a script, it applies to all the places that script is being referenced. So over here, the delivery script is placed as a component, and then it's looking at the information within the script. So you don't need to go and say, change the details of script there, details of script there, details of script there. The script, if you're pointing to it from this game object, it will update in all those places. Just in case that hasn't been clear, I wanted to point that out. Now, you can see another problem. The player can go and pick up a whole bunch of packages. That might be fine. You might want to let the player pick up all the packages. But for me, I don't want to do that. So let's have a look at our logic here and say, how can we make it that the player can only pick up one package at a time? Well, what could we do up here saying, if the other tag is package, so if we drive over a package and something is the case, well, and what do we want to say in here? We want to say, well, if you don't currently have a package. And how do we write that? Well, we could say has package equals false. That would be one way of writing it. However, there's a shorthand way we can write this is by saying in front of has package, add an exclamation mark, which is a way of saying not. Exclamation mark is not. So we're saying here, if other tag is package is true, and not has package is true, then do these things. Which, like I said before, is another way of saying has package equals false. So let's check that that works. Back over into our game, we want to pick up one package and then make sure we can't pick up any other packages now that we're using our not operator. Pick that one up. Yep, bit of a delay. Try to pick this one up. Oh, it won't let us pick it up because we already have a package. Excellent. So that's exactly what I wanted to do. We can deliver there, pick up the next one, deliver there, deliver backwards driving, pick up that one, and deliver all of them exactly as we wanted to do. Great stuff. Okay, that's all for this lecture. I will see you in the next one. In this lecture, we're going to give the player some visual feedback when I drive over a package, which I've now changed to green, changes my car to green. Then when I deliver it, my color of my car goes back to normal. So let's go and change our car's color. There's a couple of different ways we could approach changing out our player when we hit one of these packages or the place we're trying to deliver it to. One thing we can do over here in the sprite renderer is we could change the actual image itself. So we could change from this car sprite to a different car sprite. But as you can see, I don't have any other car variations that are the same car as this but a different color. I've just got these other completely different cars. I don't think that would make sense when you pick up a package, you turn into some sort of, yellow convertible. It wouldn't make sense. So, and we don't have an artist to go and make this look pretty for us. So we'll do something that's a little bit sneaky, but I think works okay. When we run over a package, we're going to change the color of the car. So for example, we can put a tint on the car. Let's see, to make it a green sort of thing. Put a green tint, says, yeah, you picked up a package, and then when we deliver the package, we can return the car back to its normal color. So we're applying that sort of tint, but we're doing that in our code. The way we need to do that is to access the sprite renderer. Now, what is a sprite renderer? It is a component. The component sits on our player, Cruisy McDrive. You see sprite renderer here as a component. And on our component, we have a number of different properties. We have the sprite, we have the color, we have whether it's flipped or not, and a few other things in here that are part of this component. So how do we access this sprite renderer? How do we go and change the sprite renderer in our code? We do that by using getComponent. So let's open up our delivery script. And I'll give you a head start on this, then I'll give you a bit of a challenge. What we want to do first of all is to pick a couple of colors. Now, it's a little bit difficult to know exactly what color we want, so there's a little bit of a tip I'm going to give you here. If we serialize our field and then create a variable of type color32, that means it's a 32-bit color, gives us lots of information. You could do just color, but that's not going to be quite as nifty for what I'm trying to show you here. So color32, and we need to give it a name. So the first one I'll do is has package color, I think. And remember, the way we write our variables is we do lowercase for the first word and then uppercase for the other words. And because this has a number of different values, actually, you know what? Let me just show you what I mean by that. So when I go back and click on my Cruisy McDrive, change his color, you can see here that we've got a red, a green, and a blue. And as I move the slider around, those values are changing in there. So it's not just one value. We're not just saying the color now needs to be a 2 or a 27. We've got a whole bunch of colors in there. And more specifically in the code we're going to be doing, see how it says RGB 0 to 255. This is a common way that artists use RGB color. There's also a setting in here which is RGB 0 to 1. That's going to be anywhere from 0, which you can see if I drag it all the way down to black. That's going to be 0 on all the values. All the way up to white is going to be 1 on the values. And somewhere in between is going to change on the particular red, green, and blue. So it's from between 0 and 1, which is a little bit friendlier for the computer to understand from 0 to 1. So if I jump back over into my script here, we need to give it a new color. And we can't just say in there like 1, 0.2, etc. We have to create a new color 32. So it knows what we're talking about. So, okay, you're giving me information for a color 32. And then in parentheses, this is where we can type in, back over to Unity, we can type in the value of this, and this. So the R, G, B, and A standing for the alpha. And I'm going to drag this all the way back up to white, which means there's no tinting applied to my car, which means it's whatever color my art asset is already. Remember, this is a tint we're doing here at the moment. It's going over the top of our blue car, so it's going to give you some interesting results. You're not going to end up with exactly the same thing. If we try to do a yellow, then it's going to end up with a greeny sort of color because it's over the top of blue. Okay, so what we are looking for is just to start off with in our serialized field 1, 1, 1, 1, and that will say just start off with white or no tint. and that's for the has package color. Now, little micro challenge for you here. Go ahead and create a second variable with the same structure for a no package color variable. So pause the video, give that a go. Okay, so we could do a copy paste. Actually, I'm going to do that. I think we're at the stage now where you understand what I'm doing. I'm going to highlight this line, copy, Control C, and then Control V to paste. So it's exactly the same. We need to go and change the variable name because we can't have these two variables exactly the same. And we'll call this no package color. And once again, we'll initialize that at this 1111, which is white. I'm going to save that for a moment. We haven't yet got to the get component. We'll get to that in a moment. But what I want to show you, if I jump back over into Unity, look for our delivery script. Here's our delivery script. You can see it has package color, and we get this little color selector in here, so we can select a color. And interestingly, it defaulted to black. I was expecting it to default to white. That's a bit of a weird one there. You can see it's on 000, despite the fact that we initialized it at 1111, but not to worry. We'll just put it up to white. And there we go. We've got the package color and the no package color. For now, I'll just put the package color to just a bright green. We can tweak that and change that later on, but the no package color we want to leave the same. Excellent. So now they're the colors that we want to put on top of our car in our sprite renderer. So let's do that, go through that process. So next what we need to do is create a variable where we can store the reference to our sprite renderer. So we want to say this is the sprite renderer we're interested in, this particular component. We need to store it in a variable so we can use it over and over, use it wherever we want throughout our script. So we'll type in sprite renderer. This is the type. It's a type sprite renderer, and we'll call it just simply sprite renderer. So it's the same thing, no confusion there. Lowercase s, so the variable has a lowercase s, and the type of thing has an uppercase s. Sprite renderer, variable, and type. Now that we've done that, we need to get it. We need a way of saying this is the thing we're talking about. So we'll add back in our start method, because this is a place we want this to happen. At the very start of when we push play, we want our game to say, okay, where's the sprite render? Aha, there it is. I'm just going to remove the keyword private and put my curly braces on a new line. Give myself a tab to move in here. And now we need to say what is being stored in the sprite renderer. So sprite renderer is our variable, and that's going to equal, and this cool thing called get component. That's saying go off and get this particular component. We need the angle braces, which are just to the right of M on your keyboard. And in here, we're going to be getting, which component do you think we're getting in here? Well, we're getting the sprite renderer. You guessed it, hopefully, maybe. And then we need our parentheses because get component is a method that we're calling. And then we hit our semicolon. So there we go. That's the foundations for getting a component in the start method and storing or caching that component in a variable. And this variable is called sprite renderer. Now we can use sprite renderer wherever we want. From this point on, it knows you are referring to this thing just here. And as we've talked about before, I can use sprite renderer dot something. So sprite renderer using the dot operator to access the properties from within here. So this is a good point to have a bit of a challenge. So I want you to change our car's color, find the right place in our code to update the color of the car when it picks up and delivers a package. And the hint I've got for you here is we need to assign our new color that we want to the sprite renderer's color. So there's just a little bit of syntax for you to figure out in this challenge, but give it your best shot. Pause the video, take that on now. I'll see you back here when you're done. Okay, so first of all, let's find the place we want to do this. I'm going to put this on the on trigger enter for the package. So in here, we're saying if the other tag is package, then we're going to pick it up. And at this point, I want to change my color. So where should we do it? I don't like doing things after destroys. It probably doesn't matter in this instance. I'm going to pop this just under where we change our bool from has package equals true. It shouldn't matter. But in here, I'm going to start by accessing the sprite renderer. This is the variable dot, and I alluded to this, dot color, because we want to change the color. What do we want to change it to? Well, when we pick up the package, it's going to be, what is it? Has package color is what we want to change it to, and semicolon. And then when we deliver the package, similarly, we want to change down here to sprite renderer dot color equals no package color. Let's save that, see how we went with that process, remembering that the color I've selected was sort of a greeny type of color, I think. That one just there, yep. Now let's click on play, drive over the package, boom, and I've disappeared which wasn't expected at all. Let's figure out what's going on there. What layer is my car on? That's my first thing I'm going to look at. I'll keep this error in just in case you're getting something similar. Layer 10, that makes sense. Is it that we've made our car transparent? That could be it as well. Let's see, the alpha, that's right. So the alpha started off at 0 for some reason. It didn't show up when we were playing around with the color, but alpha at 0 is not going to show up at all. I'm going to drag that all the way up to the right-hand side. I'm going to do the same for the other color all the way up to the right-hand side. Now, when I click on play, that was a bit of an unexpected one. Let's see, drive over that, turns green, drive over that, and turns back to blue. Exactly. But one area that I do have a disconnect now is when I pick up a package, I turn green, but the packages themselves aren't green. So maybe we'll just go and change the color of the package. So click on one, and then where are my packages? There's one package, another package. Where's the other package in my directory there? There's the final one, just holding down Control as I select that. And you know what? I'm just going to drag this top package to be down in my hierarchy next to the other packages. There we go, all the packages together. Just click on the color, change it to a bright green. It's matching the trees a little bit, but I don't know, that might mean it's a little bit sneaky to try to find them. And then just do a final test to make sure that all looks as we want it to look. When I drive over a package, I turn kind of green. When I deliver it, I go back to normal color. There we go. So we've updated our car to change colors when we drive over packages by using Get Component. Okay, I'll see you in the next lecture. In this lecture, we're going to wrap up the main functionality for this section of the course by adding in a boost. When I drive over this yellow thing, I go a little bit quicker, and then when I bump into anything else, I go slower than I was going before. So let's implement our speed up and our slow down mechanism. I'm going to give you a couple of starting pieces for this and then give you a pretty meaty challenge to sink your teeth into. So first thing I'll do in the hierarchy is right-click, 2D object, and I'll create a sprite, which will be a make this a circle, I think, just to make it look a little bit different, and I'll call this a speed up. Now, where's the speed up in my scene? Double click, it'll take me right to it. It's underneath a tree, because that was the middle of the camera when I added this into the scene. I want to hit W, move this over to the left, I think. It's under my road, so I need to put it up, say 5 in the order. Change the color, I think yellowy, orangey kind of thing makes sense, maybe a yellow. And so I don't have to drive too far, I'll be lazy, I'll put it right over near where my car is at the moment. So there we go, probably make it just a tiny bit bigger, hitting R and scaling it up a little bit. There we go, that's a speed up thingy that when I drive over it, I wished to speed up. Now I'm going to open up my driver script. Everything we do can be done in driver in this case. And I'm going to give myself 2 more serialized fields up at the top here. So serialized field, we'll get a float, and I'll call this slow speed. It's going to represent how slow we go when we bump into something. I'll initialize that at 0.1 F, just the same as move speed at the moment. I don't know what it actually is in the game. If I click on Cruising McDrive, we've probably modified this in the inspector. So it's currently hidden. We open that up, and currently the move speed is 20. Okay, so my initialization's way off in there. We'll make this 20 for slow speed. And I'll just, while I'm here, this won't change anything, but just in case we do some updates for our code, I'm just going to make that 20. And you know what? Slow speed will make 15, a little bit slower than the regular old move speed. Now I'm going to add a next serialized field, and this will be of type float, and we'll call this boost speed. How much do we want boost speed? We'll say 30F as a starting point. So we've got this concept now, these variables. One is our general old, here's how fast we're going to be moving, and we're using that throughout our code just down in here. And the other is how slow we're going to go, or how fast we're going to go. I'll save that up, and with that done, I'm going to give you a bigger challenge. That bigger challenge is going to be to create a boost and bump system. So boosts are triggers. We've just put one of these into our scene. If you look at this thing here, this is what I mean by this boost thing. It's going to be a trigger. So some things you'll need to do to that, but I want that to speed up the player when we drive over it. We're going to have bumps, and bumps are going to be colliders which slow down the player. I'm pretty much going to make everything else in my world, all these other things, houses and trees and stuff. If I bump into them, I'm going to slow my vehicle down. That'll be my approach with that. You could make separate things that you bump into which slow the player down if you wanted to, like witches' hats or cones that you place around. And we can do all of this in our driver script. So there's other ways you could do this in the future, but for now, we're just going to do it all in driver. You might want to use a tag. And the other little hint I'll give you here is remember our on event. So on trigger enter, for example, we might want to be playing around with those sorts of things. And essentially what we're doing is changing move speed to be either slow speed or boost speed depending upon what happens, depending upon whether we trigger something or we bump into something. We want to be changing what the value of move speed is. So there we go. It's a little bit of a trickier challenge, so be sure to give it a shot. This is how you learn, by sitting there and staring at it and trying to figure it out. But if you get really stuck, then you're more than welcome to watch my approach, which I'll go through after you come back from giving it your best shot. So pause the video and I'll see you back here when you've given it a good old try. Rightio, so I need to, in my driver script, I need to get rid of start, because we're not actually using that at all, are we? Start, don't need you. What we do need to have in here is some on event. So on, trigger, enter. Remember the 2D, so you're not crazy like Rick forgetting the 2D. I can just hit tab, that will auto-complete, remove the private, because I tend not to like it, and then give myself a little bit of extra formatting in here. What are we going to be doing with our triggering? Well, it's really similar to the delivery. So if we jump over to our delivery script and scroll down, you can see that we've got if the tag relates to something, then we do some things. So let's put an if statement in our driver.cs. So if tag equals, and I haven't created this yet, but we'll put in parentheses and then boost. So we need to create that in a moment. So if it equals boost, then curly braces. Let's just for now debug.log. And we'll say, you are boosting, man. Okay, just to make sure that it works before we do any more of our logic. Save that up. Hop back over into Unity, and I need to make sure that when I run over this guy here, it's got all the things it needs on it. So what does it need? Well, it needs to have a collider for a start. So we'll choose a circle collider 2D. We need to make that a trigger. Very important. We don't need to put on a rigid body because we don't want to be bouncing it around. It's just going to stay there where it is. We also need it to be tagged. So I'm going to add a new tag, which I will click the little plus button and call this boost with a capital B. Click on save. Now I need to click back on my speed up again, and I will change the tag to be boost. Now we'll see if that works. When I click on play, I can drive. And we should print out to the console something down here, which we didn't. So once again, Rick's made a mistake. Let's see what we've done here. On trigger, enter 2D, yes. Okay, so the mistake I made, sorry, I was going through this a little bit too quickly and not paying attention. It's not tag equals boost, is it? If we go back to delivery, when it says other.tag. Why is it other? Well, when we collide with something, we're getting this information passed in. And don't worry if you don't understand passing in and parameters and stuff yet. We'll do that a lot more throughout this course. But for now, we just need to know we're getting information about other. So it needs to be other.tag. Okay, and you know what? A lot of my mistakes, I make a few, I edit them out, but every now and again I like to keep them in just so you can see the thought process I'm going through if errors come up, because I guarantee there's going to be issues and errors even if you're following along with what I'm doing. You're going to type something a little bit wrong or miss it, so it's good to know that process. Also good to know that folks like myself do that as well. Okay, so when I drive over this, okay, you are boosting, man. Perfect. Okay, what does it mean to boost? Well, instead of debugging that, we don't need that anymore, as cool as it was. We want to be changing our speed. So currently we have move speed equals something, and we're using move speed in here. So when we run over the boost, when I say move speed equals boost speed. Okay, so basically whatever is stored in boost speed is going to be shoved into move speed. So if we're currently storing 30, that will be what is shoved into or assigned into move speed. So let's save. Back to Unity. We'll see if that actually worked. Click on play. Sometimes it's good to test these things with a really huge value because, let's see. Do I feel like I'm going faster? Yes, I felt like I was going a little bit faster, and it's going to stay that speed now because I haven't done anything to stop it going that quick, but that certainly feels like it's going 30. How can we tell? If I click on Cruiser McDrive, there's probably move speed somewhere. Yep, move speed is now at 30. The same as boost speed. If I unclick play, then move speed will return back to the 20 that it was. Excellent. So we have created ourselves a speed up, but we want to make sure that we stop speeding up if we bump into something like a crazy person. So that's the other thing I'm going to do in here is going to be on collision, enter 2D. Get rid of private and just do a little bit of reformatting here. My particular style, you don't need to follow it. Okay, hit tab, and then I'm going to, what do I want to do in here? Well, if I bump into something, it's just a simple case of saying move speed equals slow speed. So we're going to assign the value of flow speed to become the value of move speed, save that, and this is if we bump into anything at all. So if you wanted to have it a little bit more specific, then you would need to use some tags or need to use some other ways of doing that, but I'm just going to say, if you're crazy enough to bump into anything, then you deserve to go a little bit slower. Click on play, and make my windows a little bit bigger, I think. Okay, get a little bit of a run up here, bump into that, whoop, whoop, and then bump into that. You can see there's definitely a difference. Now I'm going slow, and bumping into everything. Now I'm going fast, now I'm going slow. Okay, cool, so it's definitely working. We've got a way that we can go faster when we hit a speedy thing. We've got a way that we can go slower when we bump into any sort of collision and slow our vehicle down again. And also you can see I'm green at the moment, so our package stuff's still working, and you can also see that I'm pretty bad at driving in my own game. Okay, so that's the core functionality I wanted to implement in my game. We can drive around a car, we can pick up packages, we can deliver the packages, we can change the color to give visual feedback, the packages disappear, we can bump into things with our collision, we can trigger things to go quicker, we can bump into things to go slower, and all in all, we've got a fun little game that you could build upon and take in a whole bunch of different directions. So that's all of the main content I wanted to cover in this section. Great work. I look forward to seeing what you've created. Please do share with us what you've got, and I'll see you in the next lecture. So that concludes this section of the course. Well done for all of your hard work. We've learnt some of the really important fundamentals of programming, such as variables, methods, if statements. We've learnt about triggers and colliders. We've learnt about components and about making references, about serializing field. There's a lot of great stuff we now have as fundamentals we can build upon. So you can spend a little bit more time working on your project at this point, or you can continue to push ahead through the course and learn more knowledge. If at this point in time things aren't quite clicking yet, don't worry about it. It takes time, it takes practice. You have to keep working on it before these things become second nature. So once again, well done for your hard work in this section. Please do share what you've created, and I'll see you in an upcoming lecture.